Hey folks, welcome to our PCA training. We got Professor B here and I'm Travis. There's a lot of people joining today, so we're going to just sit tight for a couple of minutes and let everybody pile in and get situated. But yeah, welcome folks.
Welcome. This will be the fourth time I think we've gone through these slides, so that'll be kind of so hopefully we've worked out most of the bugs in the slides. We'll always find something new. So I'm like really excited to host this and have Travis kind of co-hosting with me and getting that extra commentary that we find so at least I find very enjoyable and interactive.
Thanks, Peter. Yeah, I'm excited to dive in. It's just a big deal to host this training and give everybody access to this. So I love the idea that you had to do this live on the webinar. And yeah, let's dig in here. We got a lot of people on
And
here, so thanks for joining everybody.
yes, thanks for joining. Um, and this is going to be a four-part series. Uh, Unfortunately for everybody, this is probably the boringest of the four parts because we're going to go over like the prerequisites and kind of some of the product knowledge. So if you've been around Peplink for a while, some of this might be repetitive and some of it might be new. So just hang in with me there. But we gotta set the groundwork so everybody starts in the same footing and we all have the same level of at least base knowledge. Um, and so that's what we're going to have. The PCA was kind of thought about almost a year ago to today. It was thought about as an idea to restructure or make the Peplink certification program a little bit more robust. It might be a good word, um, or engaging. But the idea is that what is currently the PCE is basically what we've changed to the PCA. And so the Peplink Certified Associate Program covers what the current knowledge of the PCE is, but then brings it to up to date with the latest 8.4 firmware, 2023, 2024 hardware, and in control 2.13. My goal, and I think Travis is on the same par with me on this one, but my goal is that PCE becomes a lot more challenging. Making it really difficult to get, so that if you are a PCE, you can stand firm. Like, hey, I know the Peplink ecosystem inside and out, and I can configure tunnels, and I can set up the SD-WAN, and I know all the buttons and the widgets that go into it. And so the idea is to have a more complete and comprehensive training protocol to get people into the Peplink ecosystem. Is that about right, Travis? I mean,
Yeah. Yeah, totally. I think the PCA now is extremely comprehensive. We cover basically all the things you're going to need to know to become that PCE, but it's that starting point of just, it's a fire hose at first for sure, but yeah, I think that that's really why it's appropriate to have a higher tier there because there's a lot to the product and there's a lot to the capabilities, and so just learning them here at the PCA is a big step, but then yeah, taking it further and actually utilizing that in a really in-depth way, I think is, in my eyes, the goal of what the training for the PPE will be then.
and a lot of what we're going to cover today, specifically, not in this first session, but the next one, goes hand in hand with the sales specialist. We talk about all the hardware and the technology that goes into the specifications and how to pick a router. So a lot of what we're going to learn in module 2 is going to cover what a lot of your sales individual teams might need to know is, what is the Peplink hardware, what is the full scope range of the product choices, and then how do I pick the right router. And then in module 1, what we're going to do right now, which I think is, there we go, what we're going to do right now is we're going to cover basic overview of SD-WAN networking and routing concepts. So basically, if you're a Cisco person or you've got experience in networking, we just want to make sure our terminology matches your terminology. And then if you go through this module and you go, what is that? Before the next session, go to Pluralsight. I'm no paid advertisement. Go to anywhere you get training and watch a network training video. We're not going to teach you networking. I just want to make sure that we all have the same concepts understood. So the purpose of module 1 is making sure that if you are familiar with networking, when we say LAN or WAN or interface, you VLAN and things like that, you guys we have the same, you know, uh, almost gloss, making sure the terms match up. And
Yeah.
then if you watch this and you go, this is way above my head, stop at the end of this, because this is a good content video that's going to give you the introduction to the hardware before the next session, before we get into the troubleshooting and the configuring and the Visio diagrams and the labs. Go watch some Network Plus training videos. We're not going to teach you networking in this class. We're going to teach you SD-WAN. We expect you know networking, if that makes sense.
Yep, I agree. I think that's it's a good disclaimer, and it's not meant to scare you off either, right? This isn't you can learn these things too. But yeah, I think that's a perfect call to action there. If you're struggling on some of this stuff, dive in.
Yeah. Or
It
reach
will
out.
start to
We'll
learn.
point you in the right direction too. We love it. So it's, I mean, either way, it's going to be fun.
Yep, absolutely.
Module one, the module that we're going to talk about today, and we have a lot of information, so I want to go through it. Now we have also a lot of time. This is a 4-hour session. We're just going to go through module 1 and 2. If we don't finish module 2, we will cut off and then start it at the next one. So the idea here is just to get through the content. But module 1 learning objectives is introduction to basic network fundamentals, define Peplink key terminology, and my screen is being covered by this, understanding how Peplink's SD-WAN technology works from an engineer's perspective. A lot of what we do, and you'll hear me talk about subnets and IP addresses and RFC 1918, goes into our IP ranges. I expect everybody knows what an IP address is, but I am a massive fan of calculator.net's subnet tool. It basically will give you everything you need to know about any subnet to make sure they don't overlap. But if you don't know what a subnet is or how subnetting works, once again, go to Network Plus. That's the last time I'm going to say that. That from now on, it's going to be just expected. But the idea is, a lot of what we're going to talk about when we go into the configuring SpeedFusion is going to be related to your subnets and your VLANs, which include subnets. And then layer 2 and layer 3, when we talk about subnet, like routing and things like that. And so I literally have a shortcut to calculator.net subnet tool on my web browser, and I love it. I can query the different subnet ranges, make sure they don't conflict, build out a list of subnets to when I'm doing my zero IP configuration. I basically get an Excel spreadsheet, pop it in, and I can do my zero touch configurations in control, which we'll talk about. A CIDR domain or CIDR block is classless interdomain routing. A lot of times you'll hear people say something like a CIDR route. I get this all the time when people talk about, hey, I bought a slash 28 from my cable provider, and I have this WAN, and I have a LAN, and then I have a subnet. What they're doing is they're giving you a routed subnet through the peering IP address going from your cable modem to your firewall or router, and they'll talk a lot of times they'll call that a CIDR route. Really, it's just a group of IP addresses, a network in the form of a /24 or /32. But you'll hear it in reference as a CIDR block or CIDR route. And it just means they're routing that information from a peering IP address to your network, giving you more IP addresses than they want to advertise on a single peer. Subnet mask is simply a way of quantifying the CIDR
Range, maybe?
Well, it's the format, right? /24
Yeah.
versus 255.255.250. And so subnet mask is the quantification of that. So like 255.255.250 is a /24. And so once again, most of you guys know this. Just making sure we do know it. We found this really cool Network Pro guide that we would hand out that basically gives you the CIDR with the subnet mask, the corresponding subnet mask, the number of IP addresses in that subnet mask or CIDR block, and then the wildcard for it. And it was just a nice little cheat sheet. If you Google that Network Pro guide there, CIDR IPv4 cheat sheet. It also gives you some really cool basic information for like reserved ranges or RFC 1918 ranges, which we'll talk about when we talk about group networks and routing. But you can use the CIDR notation. That's what I meant, notation. The CIDR notation and subnet mask interchangeably. And so sometimes people say, oh, it's a /24, or sometimes they'll say, or they'll say it's a /29, or they'll say it's a .248. And depending on how you talk, and so it's just understanding that those are interrelated, and they're going to have those 6 IP addresses or something like that.
Kind of a
Um,
potato kind of thing, right? It's
yeah,
the same
exactly.
thing, but
And back when I started, I didn't have any formal training of networking. I was just working with
yep.
Cox Fiber and trying to set up my network. And they go, "Hey, we sent you a CIDR block," and I thought it was like this thing they were routing. And it wasn't until I started really getting into networking that I understood the context associated to it. So it's a nice cheat sheet if you're new to networking. We use it a lot. But what's most important is a subnet has a number of usable IP addresses, and then you're going to lose 2 of your IP addresses for broadcast and for the network ID. So if you'll see a /29 has 8 IP addresses, but there's only 6 usable. And a lot of times people say it's only 5 usable because you have the one that goes to the gateway, right? So if you have a /29 from your carrier, you have 1 that goes to the default gateway, 5 that you can use on your router, on your network, and then you have the broadcast and the network ID. And so those things go into count to how many IPs you have available to you.
And I think
Peplink.
if you're new to this stuff, I think it's always helpful to start getting comfortable with those 2 different formats. Go look at your Peplink router right now and look at on the WAN IP address. See what that subnet mask is, and then you can go back to that table and map that out and see what that / notation would be. So then you can start kind of learning how to do that translation or get more familiar with that kind of back and forth of how people might say those things to you.
Exactly. Just to answer some base question, this recording will go on YouTube with the presentation. The slides will be emailed out. So if you're on this, you're going to get, if you've registered, you're going to get a link to the slides and the YouTube publication. So that's there. I just want to, and then if you don't mind, because I'm going to try to watch the questions. I'm going to try to watch these questions as we go through the slides, because I really want this to be interactive. Avoid from like highs and things like that. It was fun during the welcoming, but I want to make sure that the questions I can scan through as I'm presenting. And so we want to have that. So basic general stuff. The presentation will be sent to everybody that registered for the event, and we're going to have the recordings on YouTube. And and so we're going to move on. But I'm watching the questions as well, so I can answer if you do have a question. Apologize for interrupting, Travis.
Yeah, no worries. Yeah, I'm watching the 2 here. So, yeah,
so the spanning this have a little live webinar etiquette here for how we want to do the next 16 hours of training. The spanning tree protocol. Peplink uses STP and RSTP to talk between our switches, and so it's a way of adding redundancy and loop protection, downstream loop protection, and we also have loop protection. So another thing, but the idea of spanning tree is it's a layer 2 protocol to determine which switch be elected as the root switch, and then root switches all focus on forwarding. Other switches find the optimal path to the root switch. And so the idea of Peplink, and the reason I'm even talking about spanning tree once again is because that's how Peplink talks between our switches. I know there's different options out there. So we are STP with a default RSTP, and so we auto select between them. And when we go into the technical sides here, I'm going to talk about tuning our switches and complications that we've had around it. Rapid spanning.
I'm just jump in for the beginners again, for the folks that are kind of like looking at this like, whoa, I don't know what spanning tree is. When you've got 3 switches, like in this diagram here, you're going to plug them in together in a kind of circular fashion, right? You're going to intentionally create that loop there. And then the spanning tree makes sure that it doesn't just send traffic in a circle, but if one of those switches dies or if a cable has an issue, then you've got a redundant path around. So it's a LAN redundancy strategy. But again, we don't have to go into all of those details today. But if you're just already scratching your head, that's what we're talking about here.
Yeah, a lot of time in like you'll see like a core switch stack. They'll have like 4 or 5 switches, and you have the first one going up to a core, and then you have your IDF or your MDF. Yeah, your IDFs. You'll have your switches stacked. The first one goes back to the core, and the last one goes back to the core. And that way, if you have something breaking inside, and spanning tree helps it determine which path is the right path to go, so you don't create a loop. But it's not the same as loop protection if someone plugs 2 cables into the same switch. That's actually a different feature. This is designed assuming you've done a good job with your wiring, and it's more for optimal path detection. But a lot of times people will configure, like they just plug their stuff in and they don't realize that STP is part of our platform. And then that root election can create some undesired performance when you have a whole bunch of switches on your network. And so we're going to tune our switches based on rapid spanning tree detection. And RSTP is a upgrade of STP, and it prevents network loops by limiting unused ports. And it is backwards compatible with spanning tree. And once again, the idea is to make it faster detection and failover. If you do have a switch failure, you need to reroute that traffic in that circular pattern, but not preventing someone plugging the same cable into the same switch. That's a different type of loop. So spanning tree uses 5 port states. Rapid spanning tree only uses 3 port states. So it's once again kind of a little bit faster and quicker in how it's going to decide that. All bridges can forward BPDUs. And actually, funny thing is, I learned about BPDUs when dealing with Cisco switches, but they have this BPDU guard that'll protect against MAC conflicts, which kind of messes sometimes with VRP or HA. And so sometimes you'll have this BPDU flags on a Cisco switch that's working with other systems, and we can talk about that later. But it's funny that that's associated to RSTP, and once again, kind of get that terminology out there. RFC 1918. So there's a handful of IP addresses at 10.0.0, 172.16.0.0 and 192.168.0.0. 10.0.0/8, which means it's 10.0.0.0 all the way to 10.255.255.255. So it's a lot of IP addresses. And then 172.16.0.0 to 172.31. 255.255, and then 192.168.0.0 to 192.168.255.255. The /8, /12, and /16 CIDR ranges there. Those are what's called an RFC 1918 subnets. These are your private or internal subnets. These IP addresses should never be accessible via the internet. So they're private IPs, not public IPs. It's really interesting, and the reason why I even brought this up when we're doing our training slides is a lot of people I'll see, they'll use like a 172.16.0.0/16, kind of like a 192. They treat 172.16 just like a 192.168. And there's actually a lot more IP addresses in the 172 space than there is in the 192 space. 172 is a /12, and you have all the way from 172.16 to 172.31. So you basically have 15 /16 networks to play with on a /12 network on the 172 network. And so, I see often that, that you'll get confusions on the ranges or available ranges that are out there. 10 is obviously the easiest because it's the whole dang block is reserved. I think that's why a lot of people use it, because it covers the whole range. But I find that often 172.16 is messed up or is confused sometimes. And so people put like 172.16, or I'll see like 172.32, not knowing the range stops at 31.255. And so you have this risk that if somebody does try to access a website that is public, that's 172.32, then that doesn't work. And so often I'm going to refer to RFC 1918 ranges, and then we'll even create grouped networks with the RFC 1918 ranges. So if you hear me talking about that, that we're creating a policy, or we're routing based on RFC 1918, I'm referring to the private space defined by the standard, which is RFC 1918. That makes sense.
Another common one I see on that is people will kind of transpose the two ranges together. So they'll if they're typing in a static IP, they'll type in like 172.168, kind of like
yeah.
Merge the two.
I see that. Yeah, they'll replace the 192 with 172, and once again, you're putting in a public IP address. Jennifer asked if we support MSTP. That's a Cisco protocol, and unfortunately, we don't answer. We don't support MSTP. And I actually had somebody. I actually found a conflict where they were using RSTP and MSTP interchangeably among switches, creating a kind of a root fight among some core switches. and it was an interesting challenge. But no, Peplink does not support MSTP. Yeah. So, anyways, yeah. So I see that I see 172 often confused with public and private IP spaces. 192 and 10, I don't see that. Usually people don't mess that up, but 10.0.0.0 you really can't mess up. And then most people know 192.168, and so that's harder to mess up. It's the 172.16 and where that range starts and ends that I see confusion. But it's actually a really nice large range. I use 172.31 for a lot of my P2P handout links from my domes to my routers and stuff, because usually they're not used somewhere. There are two types of packet delivery. Well, there's more than two, but two that relevant for TCP/IP. You have TCP packets and UDP packets, or handoffs. So TCP is a error correcting or negotiated link between two PCs. So if I'm talking to Travis, say, "Hey, Travis, are you there?" Travis responds, "Hey, yeah, I'm here. Hey, let's talk." And then we start talking. UDP is me broadcasting like I am to you guys out in the field. There's no feedback outside of that Q&A. So I'm UDPing out to you guys, like just and hoping you can hear me. Versus Travis and I are talking and negotiating. He's shaking his head that he can hear me. I know he can hear me. So he's acknowledging that I'm here. And that's like a TCP negotiation between devices. And UDP is me talking to you guys. So I'm just sitting here broadcasting out, hoping that you can hear it. Now, the broadcast guys go, "That's multicast," or something like that. But the whole idea is that I can't tell if you can hear me or not. Only Travis can tell me if you guys can hear me or not.
Yeah, TCP is like a phone call, right? You're going to call my phone number. I'm going to answer. We're going to talk. Where UDP is like a radio broadcast, right? An FM station. It's just blasting out, and you can tune your radio to my frequency, right? But I don't know if you're listening or not. It's out there and it's going there. And, if you get on the fringe, it'll start cutting in and out, but you're sending it constantly no matter what, right? It's not a connection like that phone call is going to break and you're going to have to recall that person and reestablish.
And they both have their benefits. TCP has error correction built in. TCP can say, "Hey, I missed that packet. Please resubmit it." But it can also add extra latency or extra loss in the network, because if you're, it can add extra overhead, is what I meant to say there. It can add extra overhead to your network. And so, the VPN protocol, and the reason we say this, it works on UDP. So it establishes a connection via TCP. And then once the VPN is connected, we use UDP for the VPN. We're sending that and then letting the other side receive it. It's going to have less overhead to the network. And one of the cool things about Peplink Speed Fusion technology, which we'll talk about, is you actually dynamically configure either TCP or UDP for those sessions, which can help if you are experiencing lots of loss and you need to make sure that gets through. And actually, we had an issue with one of the carriers where actually TCP helped fix it because they were doing UDP throttling. But most of your broadcast data is going to be UDP, and then most of your communications data is going to be TCP. So voice and video application like Teams and Skype and VoIP are going to be TCP. Well, I guess real time your actual codec is still UDP though. Your negotiations TCP, but then you switch to UDP when they do the actual codec.
So that's interesting when you start digging into packets and watching voiceover, because you use that connection oriented. It's just like we talked about, right? It's signaling the calling, the ringing, it's establishing that path, and then you just start spewing the voice, and you don't worry about
if you lose a little packet. So actually, they use the TCP to establish the call, and then UDP to transmit the media.
Just very similar to what you can do with Speed Fusion, effectively.
So TCP is best for email and texting, file transfers, and web browsing. UDP is best for live streaming, online gaming, and video chats. Once again, the advantage disadvantages, UDP, there's no verification. If you guys can't hear me, there's no way for me to know that. Whereas the advantage of TCP is that there's an acknowledgement, but TCP has additional overhead associated to it, and so you have potential performance cost associated to TCP versus UDP. And then UDP obviously disadvantages, there's no acknowledgement. So you could have high packet loss and not know it.
Yeah, if
Oop,
you look at that radio versus phone call
my
analogy again.
sensor went, my light sensor kicked off. Hold on one second.
Sure. Yeah. So if, again, back to that telephone versus radio analogy, if you're driving and you're in kind of a hilly fringe area, if you're on a telephone call, a TCP kind of connection oriented call,
Moved
you're going to
into
go
it.
in the valley, you're going to lose your call. You come back up, get good signal, call the person back, you go back down, you lose the call, right? You're up, down, you're up, down, up, down. Or if you're on the radio thing, it's just going to kind of fade out and then it's going to come right back on. You don't have to do any extra work. There's no extra overhead for you to get back into that stream. So you can see where different scenarios, you'll start to see those inefficiencies show up sometimes with TCP. So again, neither is better. They're just different and, more appropriate in different scenarios.
I do find that often I'm told, okay, what can I do all the time that's like the best way? And actually, what you're going to learn throughout this course, there is no best way. It's based on your mission and your scenario and your situation. And this knowledge allows us to pick the best for your scenario. But I mean, I have a customer right now that runs all their tunnels on TCP and they love it. But I've got other customers that are running incredible throughputs on UDP and they love it. And neither one of them is right or wrong. It's based on their application and their mission and the scenario that they have.
Yep.
So network address translation is the ability to convert a subnet to an IP address or another subnet. Typically, when you NAT, you're taking your private range and you're NATing it to your public range. That's the standard. If you have your home, if you're connected to your home gateway, your IP address is 192.168.1, blah, blah. Your default gateway, your cable modem or your Peplink router, hopefully it's a Peplink router, is 192.168.1.1. And then you're NATing that to your public IP address that's out in the world. You're saying, hey, I'm translating all these ports and IP addresses for the one IP range that I have in my house or my office, and I'm converting that to the public range that I'd like to go out to the internet, or that public IP address out to the internet. But there's a lot of different kinds of NAT. So we have standard NAT, which once again kind of takes that private IP address to a private IP network to a public IP address so it can talk to the internet. But you also have dynamic NAT, you have PAT, and you have VNAT. And VNAT is in bold because it's a feature of our Peplink that goes into virtual network address translation, which is the idea that if I have, say I have 300 buses and they're all 192.168.50.1, you just took a Peplink router, you plugged it in, and you want those 50 buses then to connect back into your data center. Well, you can't do that because they're all going to have conflicting IP ranges. So you can't have 192.168.50.0/24 on 50 buses. It's not going to work. So you can do VNAT, virtual NAT, and take that 192.168.50 and convert it to 10.0.1, 10.0.2, 10.0.3, and each bus has its own unique number. Now, when it goes over the SpeedFusion tunnel, it's going to do a one-to-one NAT, which takes 192.168.50.10 and makes it 10.0.1.10. And so you could talk and conflict. You could basically have overlapping networks that conflict. And we're going to talk about this more in detail when we have Visio, which makes it a whole lot easier to describe. But NAT translates networks. And you can use it for incoming, you can use it for outgoing. And if you're a Cisco engineer, there's tons of cool things Cisco people do with Netgear or with NATing. And so definitely not going to
But I like the question here. You see that one, Peter?
Yeah, the advantages from Alex.
So the advantage is you don't have to renumber everything in the bus. A lot of the times it's not a new installation, right? If you've got 1,000 pizza restaurants and you've got a video surveillance system that's identical in those 1,000 locations, you can't reconfigure every single video system to be a unique subnet, right? That's so much work. You're going to lose money on that deal. So rather than that, you can keep everything identical, cookie cutter at those sites like it were. And then we just kind of lie to the network when we route, right? We're pretending that this network is really that network when we're trying to interconnect them all so that they don't overlap and you don't have this like, which one's 50.1? They all are, right? So that's where VNAT lets you kind of come in and pretend that there's a new range there so that you can network them together and talk to them uniquely.
Another really cool demo or use cases in robotics. We'll have a lot of IoT people that are building an application, and you have this localized network that is doing a series of computations, and they're writing code that's talking to these devices, and they want to have thousands of them, and they don't want to have to manage the individual IP ranges and server IP addresses and things like that. So they'll set up a small /29. They'll build their IoT environment, all the different codes, and then they can push out software updates, and everything's going to be the same. They can literally clone them and make all the same. But then when they're talking back to the servers in the data center, they VNAT them. And so all the coding is exactly the same, but when they're talking two-way communications, they can use virtual NAT to basically assign each robot its own unique subnet for talking back into the environment to talk to the controllers. And that's actually the most common use case. I personally used it when I deployed some routers and then needed to set up a access control system, and I had conflicting networks and I didn't want to re-IP my network for my access control so they could talk back and forth. But and someone anonymous said, "What's CGNAT?" And I actually don't know about CGNAT. I'm kind of on the Peplink for the last 20 years. Travis, do you know what CG? I don't.
Yeah, so that's like the 100 range. When you get like Verizon, T-Mobile, all the carriers, right? You'll get a 100 IP address.
There we go, carrier grade NAT.
And that's another one that I see tons of confusion on, just because people think it's a public IP address, right? It's kind of this weird like middle ground of it's coming in as a WAN IP address, but it's still a private range and it's still not a publicly routable IP address. And so people see that, oh, I've got a public IP. It's not 192. It's not 176 or 17. It's not 172.16. It's not a 10, right? It's 100. It's a public IP. Why can't I get my firewall, through, or why can't I get this port through? And it's because it's not a public IP.
Yeah. So Peplink is not a carrier grade product, in my opinion. So we don't even attack that world. I respect the boundaries of Peplink. We do a lot of work with some really big companies, and we interoperate Peplink with them. And there are places for every business, and I don't see Peplink running, Verizon's backhaul network. We're going to interact with their network. So we're small, medium, large, kind of enterprise businesses. But your carriers, we've had a couple WISPs use Peplink, with smaller networks. But when you talk about carrier grade services, that's really where, Cisco or some of these other guys have some features, that the switching features that Peplink just doesn't have. But when you're talking about your branches, your businesses, 99.5% of, users out there in the world that aren't running carrier grade networks, different scenario.
Yeah. So I guess the distinction there is like that carrier grade NAT, that 100 subnet, it is a private subnet, but you're never going to put that on your LAN network, right? Or basically nobody configuring a Peplink is going to put that in for a LAN subnet. That's reserved for carriers to use on their infrastructure side. And you will receive an IP address like that from one of your ISPs often. But just so you know, that's not a public IP, but you're also not going to use that as a LAN subnet range either. So again, it's kind of a weird middle ground there.
So James just put a really neat post. He was configuring unique subnets for all of his clients to connect to their VoIP data for their Fusion Hub server. When he discovered VNAT, it changed my life. It makes the work so much easier. Taking over existing networks much easier as well. So another testimonial for how powerful that VNAT feature is.
Thank you, and James. I think it's a good shout out to what you said at the beginning. And I don't want to keep saying this, but this is a good check on your knowledge base do you understand NAT? Yes. Okay. Now VNAT is kind of, you're abstracting that concept, right? You're taking it one step further. It's a little bit more complicated. So it's a good point to really see, you need to understand these baselines before you move up this stack, or you're going to run into problems and you're not going to know how to use or why to use some of these features. And so again, this is just a good example of kind of how that knowledge builds up and is utilized as you get deeper into this certification path.
Definitely. And like I said, the context or scope of this course is really about Peplink's SD-WAN. And so there's a lot of things out there that might be different. We're really going to focus it so that with the PCA is so the people that are coming new into this, they can see that. And if you understand that there are much broader capabilities here, we understand that as well, but we're just trying to narrow it to Peplink specifically. So DHCP is a dynamic host configuration protocol, and it's designed to assign IP addresses to devices or hosts. And so the DHCP is the idea of IP addressing, and there's a lot of theories out there, especially with DHCP and IPv6, because IPv6 is so much more difficult to manage. But the idea is it's a client server protocol. It automatically provides IP information to a host with its IP address and corresponding data like domain name and DNS servers. And there's a bunch of different options, and I'll show you how you can configure those options. And then the idea here is reliable IP address configuration, standardizing your protocol with your network. If you want to make sure all your users are using a specific DNS server, or they have a specific FQDN that they need to be referencing when talking to that DNS servers, that is there. And then it reduces network administration by simplifying the configuration of your hosts. And there are a lot more to DHCP than that. I understand that, but the idea, once again, is just to give you the base understanding that when I talk about assigning IP addresses to our network or doing DHCP scopes or DSP trusted and untrusted zones, that you understand what DHCP is. And once again, most people on this course probably do know that. DNS, the bane of all internet connectivity and most problems when you're troubleshooting. DNS converts names to IP addresses. And there's a lot of ways to do it. But mostly it converts, www.peplinkuniversity.com to whatever the IP address is where it's hosted. So you're not typing in 172, 98, blah, blah, blah to get to the IP address of where peplinkuniversity.com is. Instead, you can just go to peplinkuniversity.com and it's going to access that name. But when we talk about DNS, especially when you're struggling to get out to the internet, DNS is heavily used for communication on the internet or even a local network. And I, even as a Windows system engineer and back in the days, it's like the first thing when someone didn't work is check DNS, make sure they're properly resolving those host names, accurately. Yes, exactly, James. And so typically when the internet doesn't work, it's DNS. And I know that sounds weird because you think, oh, it should always work, but it's weird. It doesn't. And a lot of my troubleshooting, when we start talking in module 3 about troubleshooting and technologies, you'll see good, accurate DNS, and making sure you have access to good DNS is really important to a stable network. And so it's not just named IP addresses, knowing where your DNS is and how it's functioning. And some of the things that Peplink does with DNS is really cool. And so making sure you're aware of that, and then understanding that there's something called split DNS. If I have or let's say peplinkuniversity.com, I could have a public peplinkuniversity.com, and I could have a private peplinkuniversity.com, and that could be used for my Active Directory controllers and my printers and everything in my office that's Peplink University. And so I could have split DNS where if you're, inside my network, you're talking to my internal DNS for peplinkuniversity.com. But if you're outside my network, you're going to peplinkuniversity.com and getting different public IP addresses that only I want you to have, like www or remote.peplinkuniversity.com and things like that. Whereas this one has, printer 1 and printer 2 and finance computer 1 and finance computer 2. And so that's called split DNS. And I'll reference split DNS when we start doing the network training part or the product training part of it. And so I just want to make sure that you guys understand where I'm coming from when I mention it. And DNS, if you're a systems guy, has to be the bane of network for you because it's everybody. James said, it's not DNS. There's no way it's DNS. And then it was DNS. I'm reading James's statement there because that is basically the truth.
Yeah, that's life. If you're troubleshooting at work, it's very often going to be your problem. And I don't mean to blame anybody here, but if you're using the carrier's default DNS server, you're setting yourself up to have a problem. Like if you look at these massive, like if you just read the news, right? I'm not going to pick on any given ISP, right? But pick a cable company, pick an LTE or 5G provider. They'll have a nationwide outage, and if you really dig into it, it was really just their DNS server that went down half the time.
Their DNS server went down and shut the whole network down.
So if you didn't specify your own fallback or your own custom DNS server, you didn't have internet, but you actually did. You just didn't have DNS half the time, and so yeah,
it's a fun troubleshooting step. Okay, so LAN, it's yes, it stands for local area network, but it's a commonly misconfused, especially when I'm talking to Cisco guys out there, because everything on Cisco's interfaces. There's not a LAN and a WAN. It's like interface 00 and interface 01, and this is an inside interface or an outside interface, or Peplink has LAN and WAN. So LAN is local area network. It's typically determined to be your inside network, your private interfaces or your private infrastructure. And so when we talk about LAN, we're saying your private network, that RFC 1918 space. Now it doesn't have to be RFC 1918. I like in my network, I have a BGP, and I have my LAN of my BGP infrastructure is actually my public IP space. So there is times that LAN isn't private IP space. It can be public IP space, but the idea when we talk about LAN, it's the inside of your network, not like of your router, and then you have the WAN that goes outside your router. But I don't know why, but when I'm talking to like when I'm working with a lot of my hospitals and stuff like that, and I have a lot of these these teams of Cisco guys will be on the network calls. I'll say, oh yeah, just plug in the LAN interface, and they go, which one? I mean, any of them, it's my LAN. They want to know exactly which port, and for me, I don't care. And so it's just important to understand that when we talk about LAN on the Peplink side, we don't configure our interfaces the same way a Cisco person would. We have VLANs, and we can tag and we can trunk or access those ports based on that VLAN, but we don't have interface individual settings, at least accessible to on the GUI. And so the idea here is that the LAN is our inside of our network, and typically it's your private IP range. I mean, it can be public, but typically it's your private IP range. WAN stands for wide area network. It's used to describe telecommunication networks that connects networks and devices across large distances, such as from one city to another. This is our internet. WAN and internet or outside network, they kind of go hand in hand. And once again, the idea here is to bridge that key terminology. So when we talk about our WAN interface, we're talking about something accessible to the internet or the next hop upstream. So if we're going up towards the internet versus down into our private network, if that makes sense. VPN stands for virtual private network, and it's basically the idea of connecting two local networks over a WAN. You can actually do VPNs on the LAN as well, but once again, typically, and because typically it's connecting two sites or a user to a site via the internet or via a WAN interface. Nodes or endpoints are just devices on your network. So often we'll think of a laptop on your Wi-Fi as either an endpoint or a node, and it's just simply saying something that's connected. So when we talk about nodes or endpoints, you'll see me drawing schematics in module 3 about we're making up the network, and we'll say, oh, this node or this endpoint. I'll use those interchangeably, and I apologize if I do. But they could be printers, virtual machines, desktop computers, wirelessly connected computers, laptops, phones, etc. It's just something connected to the network. 5G. This is kind of a joke slide. I put this intentionally. 5G, there's 5G and then there's 5 gigahertz Wi-Fi, but 5G simply stands for 5th generation. It doesn't mean anything beyond that. And that, a lot of people say, oh, AT&T doesn't have 5G. It's fake. Well, no, it's their 5th generation network. And there's no set stand in stone on how that functions as far as 5G is concerned. I mean, Verizon's 5G focused on millimeter wave. T-Mobile's focused on low bandwidth or low frequency. And so it's not either one of them are wrong. It's just the 5th generation. It's the next generation of wireless, a higher throughput, using new technology to increase the amount of bandwidth that we have to these devices. And it's using the 5th generation technology. But more importantly, if I say 5G, I'm not saying 5 gigahertz. I will specifically say 5 gigahertz. The other thing is during the training, I will always say 5G cellular or LTE. So whenever I say the word wireless, I'm meaning wireless LAN or wireless WAN. So Wi-Fi, not cellular. Cellular to me is, even though it is a wireless technology, I'll never refer to it as wireless during the course of our training. I'll always refer to it as cellular, or I'll simply say 5G, but I'll never say Wi-Fi when I'm referring to cellular.
Yeah, I
And
think
that's
that's
why,
a good one to point out. Like Wi-Fi has become just a Kleenex type of term, right? People just call internet Wi-Fi now, and Wi-Fi in my world is a very specific technology isolated to that protocol, and I think that's very much in line with what you're saying here, Peter, as well.
yep. Yeah, it's just I put this slide here really just for me to remind you how I talk. And then we added some cool pictures and it became neat. But the idea here is 5G is referring to the 5th generation cellular internet technology as we're talking.
I think the other one that I want to throw out there too, just because the confusion is so ripe out there with marketing, is, you see the telcos playing games with these terms a lot. And so like another example is I'm seeing like the wireline providers advertising 10G. Well, what the heck is,
Yeah.
but
What is
they're playing with these terms intentionally, right? It's like
yeah,
10 is better than 5, right? That's the kind of mentality that they're trying to attack there. But they're talking about a 10 gigabit fiber port versus a 5th generation wireless technology. They're talking about completely different things.
which
And
goes into
yet,
the next slide. So
okay, cool. But yeah, they're
yeah,
just
so yeah, the idea of
confusing
this
end
is
users
also
like crazy with that stuff. And
yeah, it's really fun when to try to decode the marketing initiatives there. Um, but
fun.
so 5G is once again 5th generation, and that matters especially when we talk about our CAT modems or category modems. And if you're a network person, you've dealt with Cat 5 cable or Cat 5e or Cat 6 or Cat 6a. It's the category of the Ethernet cable. So when we talk about category modems, that actually is what matters. um, that's what matters when we're talking about 5G is the modem, the hardware that's being used. And a lot of times we'll get someone say, "Oh, hey, my iPhone is faster than my 5-year-old BR1, but I've got these big antennas." Well, yes, but your iPhone's probably a Cat 21 modem, where that BR1's probably Cat 3, and so the hardware is what's going to determine your capabilities, not the technology, not the 5G or the LTE or the LTEA, and that goes into even if we want to talk, if you want to learn about Peplink sales, that goes in even to competing with other products. When we talk about what modems are in there, Peplink invests in really good modems. We started with like Cat 3, but are we standardized on Cat 6? Whereas a lot of our competitors were standardizing on Cat 4, which offer with our Cat 6 modems offers much higher bandwidth capabilities and better band support, in other words, frequencies. And then they upgraded to Cat 7 to standardize on the same 300 megabits per second, but adds more frequencies for like T-Mobile Band 71 and things like that. But once again, staying on the higher end versus like the Cat 3s and the Cat 4s, which some of the competitor products are using. And then Peplink said, that's not even good enough. We're going to go to Cat 12. So they went from Cat 6 to Cat 12 when we started doing like the transit duos and getting those high performance, the higher performance, especially like the HD4 MBX started out as a Cat 12 modem instead of a Cat 6 or 7, giving them more better LTE. And these are all 4G. These are all, LTE, LTEA, 4G connections. And now we're at Cat. I actually don't know what the X62 is. That Cat 21 or is that still Cat 20? I don't. We've now switched to chipsets, and I actually don't know anymore what the Cat 21 like if what the new X62 one is, because now we've switched to chipset numbers instead of category.
Yeah, on the 5G side, the 4G fallback is always a little bit. It's 20 or 21.
Yeah.
But they're always a very high throughput 4G experience on the 5G.
Correct. Yeah. So when we're talking about our 5Gs, we're going to like Cat 20 is your 4G network, and then but like our latest stuff is running on these X62 chipsets, which we'll talk about in a little bit. But the idea here is the lower category is going to have less throughput and less frequency options than the higher category. And like I said, we're now going up into category 20 and I believe 21 for on that LTE category range.
Yeah,
And
there's
so
just so much nuance to the topic of LTE, right? LTE
yeah,
does not imply what speed it is. You've got to dig into the category, and
that's
a lot.
exactly what I was saying. Yep. And that also goes into not confusing with Ethernet cable. Cat 6 is not Cat 6 Ethernet, it's Cat 6 cellular modem. And so if I'm referring to Ethernet, I'll try to refer to that as Ethernet. But typically, if I'm talking about our cellular modems or talking about our modules, we'll say it's a Cat 6 module. It's a Cat 12 module. I'm not saying Cat 6 cabling. I'm saying category 6 LTE modem or hardware in the module. Bandwidth is refers to the amount of speed you're going to get in a point of time, usually referred to as kilobits per second, megabits per second, or gigabits per second. And the key here is this lowercase b bits. There's 8 bits in 1 byte. So capital M, capital B would be megabytes. Capital M, lowercase b would be megabits. And I've had customers say, hey, I'm only getting, 20 megabits per second. And actually they're getting 100, like over 100 megabytes per second. And so it's important to understand that the lowercase b is the smaller, it typically what refers to as megabits per second. And that's what most of your speed tests are going to be. But if you're doing file transfers, like on a server, you might see that in megabytes per second, which there's 8 bytes in a bit. But then the PS, the per second is we're going to get bandwidth. So if I say you have a 100 gigabyte plan and we're getting 20 megabits per second, we have we can transfer 100 megabytes or gigabytes, and then the speed that we can transfer that is at 20 megabits per second. And so just kind of throwing that out there for standardization of terminology.
That's kind of one of those, like, for when you look at the PC, like the sales specialist all the way up to the PCE, that's one of those like early indicators when you're talking to somebody and they start confusing bits and bytes, like, which kind of end of the spectrum they're going to line up on. And so those are just baseline fundamentals that you need to really know stone cold if you're really aiming at that PCE type of track. Those are, again, just those fundamentals that need to be really well understood.
Modem it stands for modulation demodulation, or some will say modulator demodulator, and it converts an analog signal to a digital signal. With the advent of everything going digital, fiber, and even like fiber optic, and like some of our category cellular modems and stuff, a lot of them are still pure digital signals these days. And so there's actually not a modem, even though sometimes we'll refer to it as a modem. There's actually not always a modem. But a modem is simply the idea of converting an analog signal to a digital signal. The router in the modem is what is the IP addressing. So a modem by itself, the chip, is simply converting that analog signal to a digital signal for you. And then the router or the gateway is doing the NATing and the IP translation for you. So it's just interesting to think about. But the modem itself is just the idea of taking that RF signal and converting it into a digital signal so the computer can read it.
Yeah, from a technical perspective, if you look at like a BR1 Mini, that's a modem and a router in one unit, right? It's a router with a modem inside of it. If you look at the Balance 2, that's a router. There is no modem inside of that. It's just a router. And so it may be one or the other or both, really.
Here we're gonna start getting into Peplink terminology, specifically outbound policy. I have heard this referred to as route policies. I've had this referred to as traffic shaping. I've had this referred to as SLAs, I think is what I've had this referred to as before. The idea of outbound policies for Peplink is determining the flow of data from LAN to WAN networks. Primarily, it can go out speed fusion, other things, but the idea is controlling the flow of data through your network. So if I've got a TV and it has Netflix and I want it to use my cable modem, I could say send my all the TVs on my network, out the cable modem. And that way, when they're streaming their Netflix, they're using my cable modem. They're not wasting my high quality bandwidth. And we're going to go really into outbound policies in module 4, I believe, is when we're going to get into them a lot. And we're going to have an entire worksheet. I'm going to bring up demos and show you guys how to do it. But even right now, I am presenting to you on my BR2, and it's Wi-Fi connected to my network. And the reason I did this is because there is a storm coming through Florida, and I am supposed to lose power. And so I've disconnected from my monitor. I've got my USB cable connected to my laptop. My laptop has a battery. My internet has a battery. So if my Wi-Fi drops because the network goes out, or if my cable internet here at the office goes out, I'll switch over to the my bonded T-Mobile. But the idea is that with outbound policies, I'm saying, hey, send my Zoom traffic over Speed Fusion WAN smoothing. So that way, right now I'm wasting data because I'm using WAN smoothing with only one internet. But in the event that my Wi-Fi fails, it's going to go over to my bonded T-Mobile, and it's going to use WAN smoothing to make sure that our presentation continues to operate. And so, just a funny haha, but that's the situation I'm in today. So we'll see how that works. So, but that's done in outbound policies. We control the flow of traffic through outbound policies, and sort of like DNS. The first thing I look at when someone complaining, does it have internet? Is it able to get on the internet? DNS, and then how are their outbound policies configured? Because most of the time, that's where you're going to see a problem.
Yeah, I think that's one of the really common things I hear is, I set up Speed Fusion, but it's not working. My calls are still breaking up. And, 9 times out of 10, they have not set the policy to send those calls through the Speed Fusion tunnel. Setting up the tunnel won't automatically protect everything that you've got running. You have to map it. And that's a feature, right? That's great because you don't have to utilize that great resource. Like you said, you can save that for the important things and use the less important stuff on the less protected connections or paths.
Yep. And you can you can interchangeably transition or seamlessly transition between these different connections. I can say, some traffic goes out my cable, other traffic goes out the fiber, some traffic load balances seamlessly between the both of them, and then some traffic goes out of bonded Speed Fusion connection that combines the cable and the fiber, and we can control that traffic dynamically, as your mission dictates the outcome.
I think the Cisco crowd really, the light bulbs start to go off once they grab a hold of what the outbound policy manager does, and that's where things really start to get fun, I think, for those folks.
I usually win my Cisco guys when we start talking about outbound policies, because it's really powerful and super easy. And that's once you understand you're sending this source to this destination through this medium, whatever it's internet or bonding or VPN or IPsec or whatever, and I'm sending that traffic through that tunnel, it changes the way that you operate and really understand how SD-WAN works. I think outbound policies and inbound DNS is actually like the most powerful SD-WAN functions outside of Speed Fusion that we have.
Yeah, I know what you mean. Definitely.
IPsec stands for IP security, and basically it's encrypting data between two nodes, 2 points, and then creating a tunnel between them. And so it's prior to Speed Fusion, it's probably still to this day. I mean, I'm not an IPsec expert in any way, shape, or form, but probably the most commonly accepted form of VPN out there. And so it can be used for. I mean, I used IPsec back in the university days to actually secure my endpoints back to the AD controllers, because everything operated on public IP addresses. We had no NAT. So we wanted to make sure students weren't talking to our servers, and so we established IPsec on the data on our inside of our net, on the LAN of our network, because it was all public IP addresses. But IPsec is commonly used to connect your sites together. Connect you to AWS or Azure, or connect you to your mobile unit through non-Peplink routers. And some people try to use Peplink routers for IPsec, and they don't understand the power of Speed Fusion, which we'll talk about. But IPsec is basically a VPN protocol that connects two sites together, and it can do a lot more. If you're an IPsec person, I fully understand that it does a lot more. But the idea is that it's a VPN protocol that connects two nodes together on usually WAN networks. GRE tunnels is generic routing encapsulation. It is not a VPN. It's a tunnel, right? I get confused with the terminology because some people call it a VPN and some people don't. but you can do GRE over IPsec. It's like a communication protocol to bridge sites.
Yeah, I think it's just like with the IPsec, you've got the encryption. You're encapsulating it too, right? You're kind of like hiding it from the internet in both cases, but it's that layer of security. So it's it's not the same in the TCP versus UDP, but they both kind of have uses and places, I guess, if you compare the two.
Yeah, I mean, if you're looking at this picture, you have GRE tunnel that's connecting these two physical IP addresses, and you have a tunnel, and then you have IPsec, and you have your encryption, your decryption. So the GRE tunnel, I believe, isn't encrypted. It's simply just throughput. It's connecting these two sites together.
Yeah, you'll see
And
carriers use GRE a lot to just
all the
hand
time,
you
like we
a
use
virtual
GRE to talk to
connection.
Verizon. Yeah. DNS, we've kind of talked about already, but um, DNS translates human readable domain names to IP addresses. They put a little pretty picture here for you. You can kind of see a computer goes to a DNS resolver if it wants to go to peplink.com. If it doesn't know what it is, it's going to go up into a root server. Then it can go into the TLD server and authentication authoritative server, which would be your like your name servers, and then access the website, and then it's going to go and talk to it's going to talk to the website. Um, and so the idea here is there's a lot of internet issues related to DNS. I could probably host an entire course on it, but luckily there are courses on it. And so and I'm oversimplifying this for the essence of time, by the way. So the idea here is key terminology and definitions, not how does DNS work. But as the other person said earlier, most internet issues are DNS related, and there's a lot of steps here in DNS. And there's name servers, and there's DNS entries, and there's split DNS, and then there's just they go down. Somebody makes a change, and then it doesn't work, and then everybody just perceives the network to have crashed when really there was just a failure of DNS. And so the idea of this schematic is to kind of show that there's a lot of pieces in DNS, not just an IP address. And any of these pieces can fail, and the entire DNS system fails. And so you want to make sure you have good DNS servers on your network.
Yeah, I think the Peplink product itself really helped me learn how DNS works.
It did.
For me, it was one of those things where it's like you can only read so much about it before you have to do it to really learn it. And Peplink has it all implemented. So you've got an authoritative inbound DNS server. So you can really dive in and actually learn the concept, whether you're doing it for production or not. You can set that up and see how that works, and yeah, really just grasp that concept without having to compile code and do all this other stuff that larger scale DNS servers you might be doing. And yeah,
it's funny because my very first Peplink router was the Balance 300, and I used it as an authoritative DNS server between AT&T and Cox. And so I had AT&T DSL, I had Cox cable, both business services, both. I had 2/29s between them both. But the problem was that I had a mail server and I had an Exchange server. So I had one of those Exchange servers back in the day when you didn't have it in the cloud. And so, but it was like mail and mail two, and mail went to the first one, and mail two went to the second one. And then you had like remote, which accessed remote desktop, or we had SharePoint and things like that. And then I got the Peplink Balance 300 with the load balancing and the ability to actually control the traffic. But then it had that authoritative DNS server, and I was actually able to then set up www.petersoldcompany.com and have Cox and AT&T. It's just a checkbox. Use this IP address and use this IP address.
Yep.
And then I could unplug the Cox cable internet, and AT&T, www.petersoldcompany.com still worked. I didn't have to I didn't have to do round robin DNS. I didn't have to set up mail and mail two, or W and www1 and www2, and then have a CNAME that went to, like, it just worked. And it was the first time I ever used Peplink, and it actually taught me a ton about DNS and load balancing and policies, because I was able to really have that visible control of my company's DNS for the very first time ever. Otherwise you just back in the day, I used to just, go to GoDaddy, go to names, and just add an IP address there, and voila, my network started working. And so it was a lot of fun to move that into I learned about name servers. I learned about pointing those name servers and registering the name servers with the registrars and making sure that it all came in, and all those pieces that make DNS function, you can do inside of a Peplink, and it's a lot of fun. I mean, it was fun for me to learn.
Yep. It broke my brain before, I had to like break my brain to learn it, but yeah, Peplink was the tool that allowed me to like cross that chasm. I was able to actually grasp it then because it was there and it was easy to use. I could do this really powerful thing without a whole bunch of extra legwork, and I could just focus on the concept instead of all those other details.
And we talked about NAT. This is just a visual representation of that. So once again, you have your network, 192.168, and then that goes to your router and gets natted to a public IP address, your cable modem, your DSL, etc. QoS stands for quality of service. And the idea is to assign priority to data going through your network. And so if I have a Zoom call, which we're on now, and I want to say, I want Zoom to be the priority. I want to give a priority to Zoom, or I want to give a priority to my VoIP traffic, or I want to give a priority to maybe a mission critical business application that's hosted in the cloud. QoS is the idea of being able to define those applications and then tier them in a priority or a quality of service. And that's what we're doing, is we're assigning priority to specific applications. And Peplink has evolved dramatically over the years in QoS management. And what they've done in 8.4 with multiple groups now and dedicating bandwidth to specific applications is really cool. We're going to learn about that later. But the idea is QoS stands for quality of service, and the idea is prioritizing applications or protocols in your network above others, so that if someone is downloading their Steam video games and you're trying to have a Zoom call, hopefully your Zoom call takes priority on the network, even though they're using all the internet to download their video games.
Yeah, if you look at your office network, if you've got a server and you've got a virtual machine like a storage appliance that's going to do a backup, it's going to just blast that Ethernet cable, right? It's going to just max out the capacity there, and that may bottleneck some other application that's on that server. If you've got, a web program or something else on that same server, that backup's running at 1,000 megabits per second. Well, there's no room, right? It's going to fight. So you can set policies that say, no, the web service actually has priority over this backup type of application, so that it can squeeze out some capacity and make room for that application instead of just flooding it and making them all compete. So you can kind of protect those things that matter and, make the lower priority things lower priority.
I mean, I remember just a few years ago, when our Veeam backups would run, it was like, oh, network's not going to function for a couple hours. It was like 11 o'clock. The Veeams would run, and you're like, okay, well, we're done for the day. And now, with QoS properly configured, Veeam can run. It can peg the network at. I mean, we have 30 gigabits internet, so it's really irrelevant. But let's pretend I only had a gig. It can peg the internet at 998 megabits per second. And if I jump on a Zoom call, it's going to drop down to 995 megabits and give me that chunk that I need to run the Zoom call, because the Zoom has a higher priority. So yep. With QoS, I can define that application. My Zoom and my internet browsing takes precedence over the Veeam backup. So the Veeam, if no one's using the internet, Veeam can use all the internet. But if people start working, their applications take precedent priority. We can't do it by percentage, but we do it by bandwidth allocation and bill, and I will show you that later. That's going to be module 3. We're going to talk about that. Routing. So routing is the process of sending information from one network to another. Please, if you're a routing expert, don't attack my conversation here. I simply am just trying to give the basic footnotes here, because I can just imagine like one of my routing friends on this. But the idea is, if I have 3 sites, and one of them is 192.168.0.1, the other is 192.168.2.1 or 2.0/24. The other one's 192.168.1.1. Then the 172.32 is public, yes. So and then they're routing through public IP space. But the idea is that you're creating this connection. site with the 192.168.0 needs to know how to reach 192.168.1, and it uses routing. So that the router with 172.32 can say, hey, I don't know where 192.168.1 is, and it can share with other routers, or it can use routing protocols. So we can have static routes, OSPF, BGP, and different other protocols to share these networks. But the idea is that you're going to have you're going to route in order to for 192.168.0.1 to talk to 192.168.1.1. It has to go through 172.32.0.1 to 172.32.0.2, and that method there, that the idea of talking from site A to site B over here is routing, and there's going to be routing protocols that we use to do that. But the method is routing, and that's how the internet in general works, right? You're going to have a whole bunch of public IP addresses. You're not going to have private IP addresses in internet routing, but and you're advertising their space. I have 3/24s at my office here. We advertise that out to Cox and Unity and GRU, and then they say, hey, if you're looking for this public space, it's over here in Gainesville, Florida. And so we're advertising that space out, and that can happen. Commonly happens over when we're talking about speed fusion networks and talking about branch connectivity in our sites. Knowing what subnets are there and how to access those subnets is important. So if you look at this right-hand side here, you can see 192.168.2 exists through 172.32.0.3, and 192.168.0.0/24 exists through 172.32.0.1. It's kind of like a route table here that's telling this site, if it wants to talk to 192.168.2, go to 0.3, and if it wants to talk to 0.1, go to 0.1. And so that's how those route tables work. And once again, you could have an entire course just on this. I'm trying to simplify it to understand that routing is the means of talking from one site to another, and sharing that information. And it's going to happen on a routing protocol. OSPF is a routing protocol. It's the default routing protocol used by Speed Fusion, our VPN and SD-WAN technology. And so Open Shortest Path First, it's a link state routing protocol that was developed for IP networks based on the shortest path first algorithm. And the idea is that you can set up zones or areas, and then you can connect your network. So whenever you create a Speed Fusion VPN between two sites, you're going to see this show up, and you're going to have this area 00 Speed Fusion VPN, and then all the networks that are part of this Speed Fusion VPN. You can change the area, and it will affect the remote networks. But the idea is that all the Peplink routers that exist on a Speed Fusion network will know the local networks or remote networks to them of all other Peplink routers. And that's the idea behind this, is that with OSPF, they're going to share this route information with each other and know how to get to each other router automatically. I don't have to do a static route to do that. It's going to happen dynamically with OSPF.
Yeah, if you create a new VLAN on the left side router, as you apply that, it's going to add that to the routing table of the other Peplinks in your VPN. Yep. So they all know, hey, there's a new network over here. If I need to talk, if some user is trying to get to that, that's where it lives.
Yep.
So exactly. That's automatic. That's dynamic.
Yeah, I could add a guest network 172.16.0.0/24, and then boom, you actually see under Speed Fusion, it'll say updating routes. You actually see it say that, and then all the sites will get that new route table. So Peplink natively, and this is a test question, natively Speed Fusion uses OSPF. RIP-v2 is just a vector distance routing protocol, RFC 1723. It's literally, you can turn it on and you'll have a RIP shared, and it'll share the network, the routes with each other. We don't use it any common. I believe it's backwards compatible with legacy systems. If anybody on this show, if they use RIP, let me know, but I've never used it in a modern network. So can you exclude? Yes, you can exclude VLANs. It's in the OSPF configuration, which will demonstrate to you in module 3. Does Peplink support full multi-area OSPF? I believe so, but I'll check when we get to module 3. Um, the RIP v2 is destined vector. It's basically a turn it on feature, and basically anybody else with RIP v2 is going to then discover it, and then it'll share those known routes. Very similar to OSPF as far as the discovery process is concerned. If there's another router that supports RIP, and then they'll talk together and share the information. But once again, I believe this is more legacy backwards compatibility than it is commonly accepted. I've literally never met an engineer that uses RIP in the last probably 10 years. BGP has become one of my best friends lately. I think I've probably annoyed a lot of the Peplink engineers too with my ridiculous requests for BGP. BGP, Border Gateway Protocol, is effectively how the internet shares its routes. The internet works on BGP by sharing its public IP address spaces throughout the network. But it can also be used on the LAN, and it's been used incredibly well on larger LAN networks. Even they use BGP for router redundancy and active load balancing. Things like that are all done via BGP, or what it might be called eBGP, but refers to a gateway protocol to enable the internet to exchange routing information between anonymous systems. And so it talks via anonymous system numbers and instead of IP addresses. And that's how it shares those systems with each other, and then advertises the known routes that are being advertised from the BGP networks. So once again, I have Cox, Unity, and GRU. I have 3/24 networks. I have a peering IP address, so a little /30 peering IP address with Cox, Unity, and GRU. And then I advertise. I'd say, hey, Cox, Unity, and GRU, I have these 3/24 networks, so 768 IP addresses. Here they are. And then they advertise that to their peering partners, and then that's how. And then the world knows that I have IP addresses in my office with those public IPs, and that's done via BGP. And I do mine all via Peplink, and I call it BGP over SD-WAN, and I freaking love it. Network time protocol. And if you're a broadcast person, you're going to ask about PTP. I've already requested it. But network time protocol is an internet protocol used to synchronize computer clock sources in a network. Basically, SSL, anything encrypted, uses network time protocol. If you have bad time on your systems or inaccurate times on your systems, they simply won't work. If you were to go to your computer clock right now and change your computer clock to 2 hours previously and keep the time zone the same. So I'm on Eastern time. So if I was on Eastern time, and if I were to change it to 10:23 instead of 12:23, I won't be able to access the internet, any websites. I'd be able to get on the internet, but no websites that are SSL would work. I couldn't go to Google. I wouldn't be able to go to, my bank website or anything like that. They would say SSL error, and it would give me an error page. And the reason is because they all use time synchronization to share that information and negotiate the. I said PTP is coming. It's a feature, so I figured any broadcasters will ask me about PTP. It was a big deal at NAB. But we had NTP. So NTP shares the clock with all your devices so that you can make sure that they're all in the right time zone, or the time for you. So the SSL certifications and communications with anything encrypted or secure will work. Peplink has NTP servers built into our routers, and that's the premise of this conversation here. And so we're going to talk about that when we go into the UIs, and we have GPS syncing. We have some really cool NTP features built into our routers, and it's going to be a lot of fun to talk about. But basically, SSL will not work if the time is wrong. That's the point here. FTP, File Transfer Protocol. It's a TCP based protocol that allows you to send files between systems. This is really important when you have unknown systems. Like if you have two Windows systems, you're talking on a local network, it's very unlikely you're going to use FTP to talk, because you can just use Active Directory authentication and SMB. But when you're talking over the internet and you have unknown systems, FTP is like a standardized protocol that allows you to transfer files. UDP and TCP. Once again, we've already talked about this a little bit earlier. But the idea here with UDP is, if you notice, it's request, response, and that's it. I mean, there's no acknowledgments. When we talk about TCP, and the reason why I'm showing you this diagram is it's really important when we talk about TCP ramp up and TCP optimization and some of the speed fusion features around TCP. But the sender's going to send an SYN, and then it's going to receive an acknowledgement, an SYN acknowledgement, and then the sender is going to send back an ACK. And we can do policies, outbound policies, based on fastest response time. So the router is going to send an SYN to a whole bunch of destinations. And then the first one to receive the SYN ACK of that WAN, that's the fastest one. And it's going to then send the ACK out the proper WAN. So when we talk about fastest response time routing, remember this picture. Because this is our fastest response time routing. We're sending an SYN over multiple internet connections at the same exact time. The first one to respond with that ACK, that's the internet we're going to send our ACK to acknowledge the shakeoff. And that's how we do fastest response time routing is this picture right here.
I like the question here, Peter.
Yeah. Oh, go ahead.
You got any thoughts on the question?
I didn't based on this. So if you have any thoughts on it, you're more than welcome to attack it.
I think the person asking the question probably knows a little bit more about this than I do, but right away, what I'll say is I block quick a lot because it kind of hides some of the application specific information that I want to use either for QoS, but I think in this case, you're saying, what about quick when you're trying to do fastest response time? So Quick's kind of a background rabbit hole protocol that we don't need to go into a lot of details today on, but yeah, I block that a lot just to make things behave more in line with how I want to control them, I guess, instead of automatically doing what Quick wants to do.
There you go. I block DNS over SSL as well for that same policy. So, okay. So that's actually the purpose of this image, is to be able to show you the difference so that when we talk about outbound policies and TCP optimization, we'll have that answer there. DHCP relay is a service that basically allows us to receive a DHCP request and then send it to a DHCP server. This is very common, especially on branch sites. What you might have is a branch site with a VLAN. And then they say, hey, we want to have a centralized DHCP server that manages all of our IP address across all of our VLAN and networks and branch sites. And so you need to tell traffic at a local site, hey, where's my DHCP server? Because if you don't have a DHCP server and they go to an IP address, it's not going to work. And so you'll see DHCP relay. Basically, the router will send that DHCP request to the DHCP server. The DHCP server can then respond to it, and then it'll relay that back to the client that asked. You feel like that would take a lot of time. It really doesn't. It's very quick. But it does matter. And then we'll talk specifically about this when we talk about speed fusion and the tunnels and waiting for the tunnels to come up and DHCP failures. And so we'll talk about some of that in module 4 when we talk about troubleshooting. But the idea is that DHCP relay is the idea of receiving being a local agent for DHCP and then relaying that information to a centralized DHCP server.
Yeah, you start getting into like OSI model stuff on that. If your DHCP server is outside of your broadcast domain, then you're going to need relay to kind of connect those layers and get everything talking. Again, a bit of a rabbit hole there, but
so DHCP trusted versus untrusted. Trusted ports can source all DHCP messages, including DHCP offer and DHCP acknowledgement packets. Untrusted ports can source requests only. And so the idea is, imagine you have there you go. So you have your router, it's plugged into port 01. You have 2 laptops or PCs plugged into 02 and 03. These are untrusted ports. They can source DHCP. They can say, hey, can I get an IP address? But the only port allowed to respond is the trusted port. And if any of you guys are SMB network guys, I often, prior to getting DHCP trusted versus untrusted here, I would have a network outage and they're getting 192.168.1 IP addresses. And you're going, how are you getting a 192.168.1? The network is 172.23.0. And somebody thought it'd be a really good idea to go to Best Buy and pick up a Netgear Nighthawk, Wi-Fi 7 router and plug into the network to boost Wi-Fi in their office. Well, they plug in the LAN because it says LAN and they're plugging into the LAN. Well, now they're broadcasting 192.168.1 IP addresses and the whole network crashes and goes down. This prevents this. If you plug in a DHCP server, a rogue DHCP server into your network, and you're only trusting the path to your DHCP server, then someone can plug in a DHCP server, enable DHCP server, try to intercept your request, and hackers will use rogue DHCP to redirect traffic to them. So the idea here is you can do untrusted ports on your switches, and then it basically makes sure the PCs don't get that rogue DHCP server. They only talk to the trusted DHCP server.
Yeah, you see this a lot in like hotel networks, or if you've got an apartment building where they're providing internet via Ethernet jacks, people accidentally do this all the time and cause a lot of problems on networks if you don't have your switches set to filter that. And super handy feature.
Super handy feature. Radius, remote access authentication, dial-in user service. This tells you how old this technology is. We used to use a Radius server for like dial-in ISP. Right? You'd have that dial in, authenticate, and then provide internet. Radius is basically a centralized authentication server that allows network appliances or devices or nodes to authenticate against it. Commonly referred to in modern security as 802.1x. If you're doing network based security, Wi-Fi or Ethernet port, you're gonna have a Radius server. There are other forms of it, but you're gonna have a Radius server, and the Radius server is gonna say, "Hey, I've detected someone plugged into this Ethernet port. I need a name and a password." You type in your Active Directory or your credentials, and then it will say, "Yes, that's authorized on the network," and then it'll put you on the network. So Radius servers are used for VPNs, for like VPN users, Wi-Fi 802.1x, LAN 802.1x, and so it commonly now referred to as a network policy server (NPS), but it uses a Radius server in the back end.
Yeah, you'll hear AAA thrown out there as well.
Yeah,
often as another term that you'll hear kind of interchangeably in this authentication, authorization, accounting. I can't remember what exactly all AAA, but
the first three terms on this, I don't believe are network terms. They're more SpeedFusion terms, which we're going to talk into later. So I'm actually going to skip those. It's an inappropriate time to talk about them. But once again, DHCP relay is a DHCP relay agent is a host that forwards DHCP packets between clients and servers. DHCP trusted versus untrusted is the trusted ports can source all messages, and untrusted ports can only source requests. And then a Radius server is a centralized authentication server, and it uses for authorizing users access to a network. And that can be in Peplink, even our own GUI. If you want to secure that to a Radius server, you can. So there's a lot of purposes to Radius, and we actually have a Radius server section in our router that allows you to pre-program those Radius servers. SpeedFusion VPN is our kind of proprietary, awesome upgrade to all things VPN. Our regular VPN, we call PEP VPN, is sort of our response to IPsec, but SpeedFusion VPN is the idea of using multiple multiple internet connections to establish a VPN, and you can use those multiple internet connections in different ways. So first, SpeedFusion VPN offers benefits of IPsec plus a variety of performance, reliability, and security features. Every WAN-to-WAN link has its own 256-bit AES encryption. So if I have two routers talking to each other, one router has 4 5G modems and the other has 3 Ethernet lines, maybe fiber coax and whatever, Wi-Fi broadband or whatever. That's 12 separate 256-bit encrypted VPN tunnels that are being created. And then how we use those is the remaining 3 blocks. But what's important here is the number of separate encrypted tunnels that are created is incredible. If you're a security engineer and you're looking at this, that's 12 separate 256-bit encryptions that have to be intercepted to break this tunnel or to intercept this tunnel. And we've had some pretty cool analogies done with this, but it's pretty good. So now that we've said what is SpeedFusion VPN, awesome and secure and reliable and increased performance, we can talk about how we can use that VPN. And so the first is hot failover. It's probably one of the first original kind of ideas behind it. Behind it is I have a cable modem and I want to fail over to a 5G. But the cable modem needs to run all the time. I only want the 5G as a backup. I don't want to use it all the time. And so I use my cable modem. If the cable modem fails, then I fail over to 5G. The difference between hot failover and failover is if I'm on a VoIP call, a Teams call, a Zoom call, if I'm doing a credit card transaction, none of those, we call it session persistence. None of those sessions will be interrupted by the failure of the cable modem. So if I'm in the middle of a Zoom call and I unplug my cable modem, the 5G circuit will kick in and take over right away. And so we call that hot failover because I don't lose the connection. The connection stays persistent regardless. WAN smoothing is a RAID array for your WANs. So if you are a network or a PC guy or anything, or if you know what a RAID array is, basically it adds parity bits in the form of 100, 200, or 400% to your circuits to make sure that you have the lowest latency, least amount of packet loss possible. So it's designed for when I'm competing against like these like SLA MPLS circuits or T1 circuits where they're guaranteeing a certain, I can throw on WAN smoothing and say, hey, this is going to be a good circuit. We're going to take all these interwebs and we're going to combine them together to create the most resilient network possible. And so we use WAN smoothing sort of like a RAID array of our WAN circuits. And then bandwidth bonding is the idea of aggregating all my internet connections together to create the most possible bandwidth that I can. And so in hot failover, we're moving from one WAN to the other while keeping our sessions persistent. WAN smoothing, we're adding parity bits to make sure that session is perfect all the time. Bandwidth bonding says, give me as much bandwidth as I can. With outbound policies, I can have all three of these active at the same time and based on the application, use a different technology. And so you're going to hear these terms probably 800 times over the next 16 hours. Don't freak out. Just be aware that they exist. We're going to go into these a lot more detail.
Yeah, I think one of the kind of details that I like to point out, or it's kind of more of a fundamental, I guess, but we talked about QoS a little bit ago, right? And QoS typically is a LAN concept in most cases because the internet does not honor QoS mechanisms that are typically used in your local networks. If you send traffic up to your internet provider, they don't care what QoS markings are on those packets generally, right? Unless you have a private link from them, they're going to send it on through their networks the way they want to send it, right? They're not really paying attention to what you're doing or how you're sending it to them. So SpeedFusion allows you to overcome some of those challenges and kind of apply more of a brute force strategy to the internet so that you can have more bandwidth for applications, or you can have more consistency, or you can have more survivability. So we'll get into a lot more details on that, but in a nutshell, it's kind of overcoming the limitations of the internet and not having that QoS to keep your top priority applications working the best.
And when I first did this slideshow, you'll see the same concepts multiple times. And what we're doing is we're building on the knowledge. So first we're introducing the concept, we're introducing the term, so you know what it is. Then we're going to go into how that's used, why it makes your network better. We're going to talk about our routers because in the next module, we're going to talk about the routers. We're going to talk about their bonding limits and capabilities. And if you don't know what bonding is or hot failover is, then it's irrelevant. So the idea is to introduce the concept, but the technical details, module 3 and module 4, we'll dig into it more. Dynamic weighted bonding is an upgrade to bonding that was introduced in firmware 8.2.1 and then really brought public in 8.3 and is incredibly tuned in 8.4.1. Dynamic weighted bonding is an algorithm that will monitor and reduce the percentage of packets going over a connection with high latency to avoid congestion. So typically, and if you go to speedtest.net, you can test this and see it right now. But typically, the more bandwidth you consume, as you reach the limits of that circuit, the higher the latency. Your latency will spike. So people that are trying to achieve lower latency connections go, oh man, my internet's spiking to 300 milliseconds of latency. And it's because they're hitting the threshold, the limits of that circuit. On a cellular network, usually it doesn't have to be you, the user, sucking up all the internet. It could be the 3,000 other people on that cellular tower that are congesting that network. And we call that congestion. So if I have a 1 gig pipe going to a cellular network or going to a cell tower, and I'm on that, I could be using 1 megabit per second of data. I'm not using a lot of data, but you have 2,999 other people also using data. Even if it's 1 megabit per second on a 1 gig circuit, that's not enough internet. And so the tower has to share that bandwidth with everybody on the tower. And so that's when we start to get congestion, where the pipe is being choked by the number of users and the demand on that network. And so what we want to do is detect latency spikes to mitigate how much bandwidth we're trying to push over that link. Dynamic weighted bonding uses packet loss and latency to dynamically adjust how much it uses each WAN to optimize it to keep the latency within an tolerable threshold and maximizing bonding performance. Is that about?
Yeah, I think the way I like to look at it is dynamic weighted bonding is our latest generation of bonding technology, right? Just like we talked about 2G, 3G, 4G, 5G. And it really kind of pairs with that, right? Because we live in a 5G world now, right? We've got wireless connections all over from a WAN perspective, whether it's 5G, whether it's Starlink, there's all these new wireless technologies, but those are all shared connections, and you're going to have those ups and downs, those variations. And so our algorithms are so well tuned to pair up with these new connections that we can do the most efficient job possible. These variations make bonding really hard to achieve. If you want to bond two things together, you want the most consistency possible. And so doing this in a modern world is harder and harder. And so it sounds like kind of like, duh, of course you're going to do that, right? Of course, Peplink, you need to keep up with these algorithms. But the difference here is nobody else is doing this. We are beating the pants off of really, really well-named enterprise SD-WAN products because they came from a wireline world and they've not adopted their algorithms to these modern connections. So when Peter's coming into these competitive deals and these new connections are being brought in, these traditional enterprise SD-WAN products are falling down because they can't beat our performance. They can't take advantage of these networks the way Peplink does with our algorithms. And that's what we focus on the most, is really optimizing all of these new links. And so that's what dynamic weighted bonding does, is just keeps you up to speed with the modern connections that are out there.
Bob said he'd like to learn more about this. We're going to deep dive dynamic weighted bonding. I've got an entire lab set up over the next couple weeks that we're going to be demonstrating all of this technology in real time, and talking about high availability, dynamic weighted bonding, AT&T, Verizon, T-Mobile, Starlink. And so if you want to deep dive into this, that's what these special sessions are for. That's what this four-part webinar is for, because you can't talk about this in 40 minutes. We just can't. And that's what I was talking about this with the marketing team and Travis. And it's too much. I mean, think about it. We've already been on for an hour and 45 minutes and we're at terms. And so it's just too much information to go over at one time. And so we're gonna work through this together as a team, and we are gonna deep dive this. And when you get into module 3, we're gonna learn a lot about it. Right now, what I want to do is get you guys understanding the basic terms, so that as I'm going through the products in the next module, you'll understand why I'm talking about it and why it's so important when you're making a decision on the product. Then in module 3, we're going to deep dive speed fusion. We're going to deep dive in control and zero touch and bonding. And we're going to talk about high availability. And we're actually going to set up high availability and failover and drop in mode. So we'll go over these different things that we have. But I just, if that's something you're interested in, then hopefully you can think of this as a teaser video and join us on the next modules.
Yeah, and I think Bob, you're really speaking to something real here in that your job, Bob, is to bridge the gap, right? You're on you're on the front line sales, and so you're talking to folks that don't understand these terms and don't understand these distinctions and all these details. And so, part of this training is trying to give you those analogies and those ways to talk about this to help bridge that gap back down through the sales process as well. So yeah, this PCA is really that middle ground of, you're kind of the midfielder, right? You're helping the offense and the defense in both cases. And yeah, it's a tough battle, though. I get it, Bob.
I think Travis knows Bob. The the um the so what when we talk about Peplink SD-WAN, what is SD-WAN? And this could probably be its own argument. So I'm not asking you what SD-WAN is. I'm going to tell you what SD-WAN is. I'm going to tell you what SD-WAN is for me and for Peplink. And then I'm going to that's going to be how we define that term for us. Now, the industry says that it's software that allows you to use more than one internet connection at a time. In a nutshell, I mean, that is a very basic or broad terminology, but the idea is what I mean, there are companies out there that are claiming SD-WAN that literally add a second Ethernet port and say, there we go, you can use this as a failover, and it's our SD-WAN solution. Well, my argument to that is I used to do that with a WRT router that I bought, that Linksys, and you'd get that WRT software, and you'd have two internet, and I'd have my AT&T and my Cox, and so I don't think that that's enough personally, and so I'm going to define SD-WAN on what I think the minimum standard should be. So for SD-WAN, we should have more than one internet connection. That I agree with. Multi-WAN connectivity. We should be able to control on the application layer level how those internet connections are being used. So we should be able to do outbound policies, traffic shaping, you name it, but we should be able to use all those internet connections at the exact same time. So I think that should be a required mechanism for that is we should be able to use all those internet connections at the exact same time, both incoming and outgoing. So I believe a true SD-WAN solution should be able to load balance those connections coming into your network and going out of your network. Then we should be able to aggregate those connections. And there are competitors out there that meet that checkbox. So we're not the only one. I'm not setting a standard that's impossible to meet. I'm saying that otherwise it's just a multi-WAN router. And the ability to use those internet connections inbound, outbound, and aggregate, I think is incredibly important when we talk about what an SD-WAN router is. And you can see right there, the ability to use all those connections at the same time, the ability to load balance inbound and outbound. If you don't have that minimum checkbox, then I think it fails. And then a modern SD-WAN should have some layer of centralized management. You should be a way to manage your entire infrastructure from a single pane of glass. WAN virtualization. SD-WAN solutions provide lightweight replacement for traditional WAN routers and are agnostic to WAN transport technologies such as MPLS, VSAT, LT, etc. Peplink routers enable you to build an SD-WAN group using multiple technologies. And so the idea here is when we talk about WAN virtualization or we talk about multi-WAN, typically people, like I mentioned, they're talking about is the ability just to use those connections. But we want to be able to actually build an SD-WAN using all of these at the same time. We want to use all those. And so we want to be able to use these at all at the same time. We should be able to have secure branch networking with SD-WAN, meaning that we should be able to have our we should be able to secure that connection out to our cloud infrastructure. We should be able to dynamically change how the cloud resources are accessed. And so the challenge is how do we create that connection to our different environments and bring that all together in a centralized platform. And so what we say is, like, on an SD-WAN environment, we should be able to see all that in one pane of glass, and that kind of goes into the previous idea of aggregation. And so this is sort of a merge between SpeedFusion and outbound policies. The ability to use SpeedFusion technology to connect us to our cloud, our branches, as well as use outbound policies to change the flow of that traffic. So I create a PEP VPN between our office and our cloud services. We have internet, and I can use outbound policies to control how I'm using those internet connections based on the destination or the application. We should have a central management platform to be able to access this. We should have SD-WAN solutions dynamically simplify the complexity of associated with management, configuration, orchestration of WANs, seamless failover, the use of best mix of internet and private circuits at each location, optimized performance between sites. Using in control, network administrators gain full control over their networks using a single interface. And so from in control, our cloud management solution, we have access to all the routers. We can configure SpeedFusion, outbound policies, firewalls. And I'm going to show you our zero touch configurations. And like literally, I can factory reset the router that's on the floor right here. And in about 4 minutes, the router will come up, download its IP addresses, connect to SpeedFusion, set up its multiple tunnels, create the outbound policies, and then be up and running again. Factory reset. Don't have to touch it. That's zero touch configuration. And so we should be able to manage our infrastructure from a single pane of glass and push those configurations out without messing with the routers. Traffic steering. That's what I wanted to say, not shaping, steering. Outbound policies. Based on business policies, SD-WAN solutions allow for multi-WAN load balancing efficiently and dynamically. Actively monitors WAN quality and makes intelligent decisions to direct application traffic flow. Policies can be customized based on applications for security and performance preferences. Once configured, traffic steering requires no human interaction. Peplink routers actively monitor WAN quality via the health check and makes intelligent decisions to direct application traffic flow, DPI, and outbound policies. SpeedFusion bandwidth bonding. Establish a tunnel on all active links, splits application traffic across all active connections. Increased throughput is possible. Certain link combinations are not realistic. And that's important to say. If I have a 1 gig fiber line and a 10 megabits per second LTE connection, bonding those together is not realistic. Even though you could technically do it, the overhead and then the aforementioned performance would not be there. And so you can increase traffic when you're bonding like connections, but otherwise you're adding stability and or failover to your connection. If a link fails, the traffic is quickly routed through the second tunnel, sub-second. That's actually not true. If a link fails, the traffic is routed through the second link or additional links. Application can operate uninterrupted during handoff, hot failover, that's session persistence. And you'll hear me say session persistence a lot. And so I just want to make sure you guys understand what that session persistent means, is holding those sessions alive regardless of the state of one of your internet connections.
Yeah, I think to rewind, like session persistence, when we looked at that TCP, that SYN, ACK, SYN, right? Session persistence preserves that so that the two parties don't realize that there was an interruption somewhere in between them, right? We're hiding that interruption so that they don't have to reestablish that communication path. When your Verizon LTE goes down, you don't have to relog into your corporate VPN. You don't have to recall somebody on a voice call. That's session persistence, right? That established communication stays up.
Exactly. What is SpeedFusion active links? An active link only can be considered as an active link when a SpeedFusion tunnel or within a SpeedFusion when a WAN connection is able to reach another end's WAN IP. If it isn't able to connect to the WAN connection on the other end of the SpeedFusion tunnel, then it isn't considered an active link. And so the idea here is, if I have an ISP A and B, and then you have a private line, this ISPB private, if I don't have a private, that the other end of that private connection, this private connection can't talk to the public internet. So I would have to have a point-to-point connection here between the private connections and the on both ends. Can more than two WAN? Oh yes, we've bonded. I believe Adam has bonded like 190. Yeah, you can bond a lot of WANs. Yeah, that's definitely not a problem. I think the most I've ever bonded is 40, but there's other Peplink partners that have bonded well over 40. So, so SpeedFusion connection, you have WAN 1, WAN 2, WAN 3, and then the public fixed IP address, public and fixed IP of the WAN, and you can see that the little ... that's not an active link. It doesn't have access to the internet or to the other side, so it can't be an active link, whereas the OIND connections are both public IPs and can access the other side. SpeedFusion requirements. This screenshot this, or if you're going to get into SpeedFusion, screenshot this page. We are going to release it, but it's important to understand the requirements here. SpeedFusion is a technology, not a product. So you have the Fusion Hub, you have routers, you can connect multiple routers together, but SpeedFusion is a VPN technology operating inside of our equipment. And so SpeedFusion requires 2 SpeedFusion capable units minimum, whether that's a Fusion Hub and a MBX 5G, or a BR1 and an MBX, or an SDX and an MBX, however you want to do that. Different models of PEP can create different levels of SpeedFusion. We talked about hot failover. A BR1 Mini might only support hot failover if it's running 7.1 firmware, whereas a BR1 Mini hardware 3 running 8.4.1 can support full bonding. So different levels of different routers can have different capabilities of SpeedFusion based on their firmware version and hardware version. All Peplink routers are capable of the base PEP VPN, the basic VPN, SpeedFusion VPN connection, the PEP VPN. You need, there are multiple configuration types. We have a point-to-point, we have mesh, we have star. So there's multiple configuration types, but the public IP address, a public IP address on at least one WAN connection of at least one router. So in other words, you have to have something connect to. So one of your routers needs to have a publicly addressable IP address, and that can be NATed behind a firewall with port forwarding, but it still needs to have a public IP address and NATed. It can have a dynamic public IP address. Actually Peplink has a service called Find My IP, and we can use Peplink's dynamic DNS service. But no matter what, you need to have at least one internet connection accessible via the internet directly to establish that link. So route like my BR2 that's here is connected to the Wi-Fi as a private IP address, and then it's going out to a public, and it can connect outbound to my Balance 380 that's sitting in my office because it has a public IP address, and I'm connecting to that public IP address. And once it establishes that connection, it will then create the SpeedFusion tunnel. But you have to have at least one router with a public IP address or device like a Fusion Hub. The public IP doesn't have to be directly on the Peplink device. Like I mentioned, it can be NATed. And a lot of times, like when I'm deploying in large infrastructures, they say, hey, they have their public and they have a public firewall, and then we plug into the public firewall, their DMZ, and then they just NAT or port forward. But it has to be accessible. The public does not have to be static. It just has to be a public. And we can, if it's not static, it has to be, you're going to have to use like a dynamic DNS service. And
so
the IP,
link, go ahead.
Go ahead.
Yeah, I was going to say, if the link fails with the public IP, you're fine, because step one is they exchange all of their public IPs as soon as that is initiated. So, you've got your one kind of target public IP. All the remote Peplinks are going to phone home to that, try and establish that tunnel. And as they're doing that, they're going to say, hey, I'm this remote device. I've got all of these different IP addresses on my WANs. What do you have on your WANs? And they start building tunnels to each of those WANs. So as long as you've got a different link than what that public IP address is on, your tunnel is going to stay up. You don't have to have that public IP there right then to keep that session up. You're going to need that for a new device to come on and join that VPN,
but you at all times you need at least one publicly accessible.
Correct.
So if that one fails, if you only have one and that one fails, then it's not going to work. You have to have at least one, and then it will discover all the others. But if they're not public, if they're using that one IP as its only public, and that one IP fails, you will lose the network because the other ones are being NATed, which means they can't talk inbound to it. So you can have multiple interfaces, but you must have at least one public IP address. It can be NATed. It can be, as long as you have port forwarding, it can be NATed. But you have to have at least one. And the more you have, the more resilient it's going to be. But it is important to understand.
And there's really easy strategies to make sure that you don't have that problem, right?
Yeah.
This is not a, oh my gosh, this isn't going to work for me type of situation, right? These are really, really easy challenges to.
Yes, definitely. The public IP address is needed because it's creating a VPN, and so you have to be able to talk to something. So if you have two routers that are NATed, in other words, behind another firewall, then both firewalls, they can't talk to each other. So you need one router that's accessible from all the other routers. And then any routers that are going to be hubs should also be accessible to the internet. And that sounds complicated, but it's like Travis said, it's not. I mean, most business level services give you a public IP. Heck, most private level services give you some DHCP public IP these days. So it's not complicated. It's simply just needs to be aware that is a minimum requirement, that you have at least one public IP.
And if you zoom outside of Peplink, right, if you look back at IPsec, this is way more flexible. You have way less requirements with SpeedFusion than you do trying to support IPsec, which has way less capabilities. So
yeah,
again, these are really small problems compared to any other technology out there.
Definitely. People that are security conscious, SpeedFusion is a pretty secure. I mentioned that earlier. A secure WAN-to-WAN link establishes through DH exchange protocol. This is 4096 DH that uses public key cryptography. Perfect security is guaranteed by using DH exchange master keys derived to the data encryption and renegotiate them at random intervals. Data passing through the SpeedFusion gets protected by an AES cryptographic algorithm to provide 256-bit security level. And then once again, once bonding is set up, like I said, and that's per WAN link. So if you have 12 tunnels, that's 12 sets of 4096 DH, 256-bit AES. I mean, SpeedFusion security is above par, in my opinion.
Oh yeah, that's a whole conversation, but
yeah. We offer point-to-point connectivity. That's going to be basically connecting two sites, like a headquarters and a branch site together. So it's called a point-to-point connection. We offer fully meshed capabilities where all sites talk to all sites. It is important that it's not all routers support a lot of PEP VPN licenses. So like a BR1 only supports 2 peers out of the box. So if you have 20 sites and you throw the BR1 into a 20 site mesh, it's not going to be able to connect. One second. So Loris asked a really good question about the protocols. Module 3, I will go over those protocols. I have a network diagram, a picture, everything for you. And we're going to talk about the protocols that are used to set up the tunnels. Right now, we're talking about just the terminology, so that when we talk about these protocols, you have the base understanding. So fully meshed is going to give us the ability to talk to all sites, talk to each site, but then, like I said, you need to pay attention to licenses. And then a star topology, where you have a hub and spoke style, and you can have multiple hubs, and multiple spokes can talk to this to different hubs as well. So this does not have to be a one to many. It could be a one and one to many scenario, a lot of times people will have like two data centers and we'll do two star networks, one from each data center to each star, and then we'll use either outbound policies or DR to establish the connection between those sites.
Yeah, and
And we've
I
been
would
doing,
say too, just understand the difference between star and mesh. Make sure you understand that, because
and we're
both scenarios, both can talk, everybody can talk to everybody, but it's how they're connected to each other that's the difference. And yeah, just look
it's
through
where
that.
it's where those public IPs are. That's the major difference. Once again, if you're an endpoint and you're doing a mesh, that means that everything's talking inbound and outbound to each one. So you need public addresses because you talk inbound to those connections. And a hub, a star network, you have the hubs have your public IP space, publicly addressable WANs, and all your spokes. It doesn't matter. They can be 5G, they can be Starlink, they can be MEO and LEO and GEO, and they can be broadband, and they can be Wi-Fi WAN, and it doesn't matter. They're gonna phone home to your hubs, and then they have access to your network. And so that's the benefit of that star network um, over the fully meshed.
Yeah.
And we successfully completed module 1. I'm very happy about that. It took a little bit longer, but almost right on schedule. The 10, 11, 12. Yeah. No, 11, 12, 1. So 11. Yeah. 2 hours. Perfect. So we finished module 1. And so that would be our breaking point there. We are going to now kick into module 2. And I'd like to get this done today. That way we go into module 3 on the next one. But if we don't finish, don't worry. We'll just continue on that slide and move on. Module 3 is going to be Peplink product knowledge. If you're a salesperson or you're working in Peplink on sales, this is a great starting point outside of the terminology for you. After this module, we're going to get into the technicals like how to configure speed fusion and manage in control and set up dynamic weighted bonding and set up drop in mode. And that might not be as entertaining for you, but no, there's not a virtual Peplink router outside of a Fusion hub, but you can get a Peplink router and play with it. I do not recommend. Well, you could take module 1 exam today if you want. I forgot they're broken down into modules. The only downside is it's open notes, but we haven't published the slides yet. So maybe wait till tomorrow. Wait till they release the slides, because it is open note test. But most of it's pretty easy. I mean, if you know anything about networking, I'm not worried about module 1. Module 2, you might want to wait till the slides are out. And so, but yeah, so let's dig in, because I would love to finish this today, and I am going to kind of get through it. So Peplink product knowledge, hardware oriented. So today we're going to talk about the product lineup. We're going to talk about how to select the right product, and then unifying the ecosystem. When we talk about our hardware product knowledge, we have attributes, and we need to be aware of these attributes. So we have one major product series: the Balance 5G X series, BR series, switch, APNs, antennas. Now, there are Balance routers that have 5G and X. There are X series that have 5G. So I might review the same router more than once, because it qualifies under different categories of major series. What's important is the attributes and specs. And when I'm doing sales consulting or engineering consulting, and I'm giving people ideas on how to use these routers, this is what I'm looking at. I'm looking at, what are my cellular WANs? And if the customer needs it, how many cellular WANs? What are the client expectations? How many Ethernet WANs, and now VLANs, right? VWANs. How many Ethernet LANs does it have? And does it need PoE? Router throughput, speed fusion viewput, different than router throughput. Does the customer need RS-232 for out-of-band management? Do they need Wi-Fi AP, GPIO sensors for ignition sensing? Do they need USB WAN for out-of-band management for tethering a phone or a max adapter or something like that? How many users are going to be on the network? Do they want to take advantage of Peplink's Speed Fusion Connect Protect service? How many remote networks are we going to full mesh 40 sites? Well, then we need a big enough router that can do full mesh that can support 40 peers. Sometimes there's one spec that's it. Once you meet that spec, if the customer says, I have 50 sites and I want a full mesh, that limits the number of routers instantaneously. So there's some things, or they'll say, hey, I need a gigabit of speed fusion throughput. Okay, well then you're going to an SDX or some variant thereof right away. Even though a 310.5G might have the right WANs and the right router throughput and the right number of peers, you're going to go to an SDX Pro because you need that gigabit of throughput. And so there's some specs that as you learn the routers that once the customer says, oh, I need this, you go, oh, well then here's your router, because that's the only route, the only router for your choice. Max number of APs supported, how many SSIDs are supported, do we do a captive portal, GPS, ignition sensing, remote SIM, we'll talk about, 802.1q VLAN support, WAN as LAN, terminal block, drop-in mode, and LAN bypass. So these aren't all the features, but these are features that when I hear key terms, these are the features that drive me to the right product. And that's important when we're talking, and now I'm really talking to the salesperson here, but if you're engineering a solution or you're selling a solution, as you learn the hardware and what these attributes apply, it's going to really help you just quickly narrow down the solution. Our product series. We have our Enterprise SD-WAN series. We have the Balance series and the EC or Edge Compute series. So we have our balance routers. My very first balance router is a Balance 300. Bought a Balance 380 and a 580 after that. It's been now I run 4 2500 ECs with BGP. So it's just it's been an escalation for me as through the environment. But the Balance series has a place in my heart because it's just how we got started. And they're really designed for branch and fixed deployments is where these balance routers are. When you're setting up your data centers, you have your branch sites. When you think my branch deployments, that's going to be my balance series routers. If you need to add a layer of edge computing to that, then you can go to the ECs. But mostly you're going to sit here and play on the balance series if you're talking about branch connectivity. Affordable and robust connectivity are the BR1 and the UBR. I believe Peplink sells more BR1s than probably any of our product line. Travis shaking his head. Yeah. And what I always like to do is I'm a big fan of resiliency. So when you talk to me on sales, I don't like single cellular solutions, because what's the difference between one brand and another other than ecosystem? When you're talking about single cellular, if the customer calls you complaining about reliability or resiliency, then a single cellular solution is not going to help. If they're talking about management and ecosystem and features, then a single cellular solution works. So you go into the UBR, gives us a budget-friendly multi-cellular router that really competes in those areas where you have the ecosystem and redundancy. Now, that is my personal sales pitch. Once again, they sell more BR1s than any other product, and they sell thousands and thousands and thousands of them. But I'm a massive fan of resiliency. That's what you're going to hear me promote, and that is biased on my engineering, and so that's why Travis is here as well, because he can speak to the rest of it. But when you're looking at the BR1, the UBR, our equipment, talking about the ecosystem, the connectivity, the features, the PEP VPN, the zero touch configuration for tens of thousands of devices you can deploy in seconds. And that's the idea behind it. And then we go
just like you talked about at the beginning, Peter, it's like, you start looking at these baselines of like, okay, what's my scenario? What's the customer's problem, right? What are they trying to solve? Okay, I've got remote sites that don't have wireline. Okay, yeah, then if reliability is their issue, I'm going to need a dual radio solution. If they've got an office and reliability is their issue, maybe you don't need a dual radio, right? You can use a single radio product, but you're going to combine it with the wireline that's already there, so you have two connections, right? So you got to start plugging those baselines in.
Yeah.
And like you said, then that'll steer you to this model or this model or this model, because you have to think about what connections I have and what problems am I trying to solve. And that's where those two pieces of information really narrow your choices down really quickly.
The ability to complete the mission. And then we have our ultimate connectivity. This is my playground. I think I'm in the top category for these. Travis is laughing, but I'm pretty sure that this is my playground.
That's a
The
yes
Max.
laugh.
So now we're talking about the Max HD series and the X series. I'm a massive fan of this series. It's built our business. Um, but the idea of around powerhouse mission critical connectivity. So combining anywhere from 2 to 40 internet connections or beyond together to create the most resilient, high capacitance network possible to complete almost any mission anywhere. And that's when we talk about ultimate connectivity. That's why they call it ultimate connectivity. And these really are the shining stars of just there's no competitors to this product line. I mean, you can sign branch routers. I mean, someone's like, oh, I'm looking for Meraki X68, 68, blah, blah, blah. Oh, yeah, that's very similar to our 310 5G or whatever. When you talk about the ultimate series, this ultimate connectivity, there, as far as I know, there aren't any competitors in this world.
Mm-mm.
Um, it's so like connected. I mean, one router with dozens of internet connections. It just doesn't exist that I know of, and it's a lot of fun to engineer these solutions and play with them. And on my office, my lab that actually Travis is currently working on a new feature with, but it's the first EPX to hit the United States as far as I know, and I had it on a floor of a hospital in Lehigh Valley up in Pennsylvania, and it's sitting on my desk now doing troubleshooting and design for the next. These things are epic, and they're powerful and they're resilient and they're scalable. And so it's like when you talk about this X series routers with these modules, it is the best of the best, and that's what they right. That's what they're saying here. It's the best of the best, and it really is. And we're gonna have fun
Yeah, and I
talking
think
about those.
the earlier question of can you bond more than two connections? Yes, and the X series is where that goes into those kind of you mentioned 50 or more connections, and that's not just like playground stuff, right? You're doing that because that question of what's the problem and what options and resources do I have, those things drove you to need to do that, right? Like that's the only way to achieve that mission for that customer. And so that's why those products exist, because people need to do wild stuff out there in their everyday jobs and lives. And that's what those products are there to do. They're there to solve real problems. We don't always know what that problem is going to be. We can't anticipate some of the stuff our customers are trying to do, but those are the products that let you push the boundaries of what's possible with IP networks today.
Amen. And then we have our industry specific unbreakable connectivity, and that's going to be our transit series. We have the transit routers, and if you're new to Peplink and been around for the past like maybe 3 years during COVID, you might have seen like an emotional roller coaster on transit routers. so it's all stabilized now. We have the Duo Pro, and um, but the transit router is one of those routers that can literally be shoved anywhere. It's tiny, it's portable, it's robust, it's resilient, and you can shove it in a corner, shove it in a closet, and it's gonna get you connected. And what's really neat is they're not super expensive. So you're getting a really robust router for a good price. A little bit more expensive than the UBR and the BR1, but not as expensive as your ultimate connectivity routers. And so it's a great middle ground router for someone looking for that baseline connectivity, but wants a little bit more than a BR1. Um, and then we have our FirstNet series routers, and these are going to be certified for use on FirstNet. And it's FirstNet and ESN. They're going to mix between these different routers. I mean, some of the HD routers, some of the BR1 routers are FirstNet certified or 5G, and that's why you're going to see some redundancy. And the idea here is going to just let you see which categories these things fall into. And then we talk about the ecosystem or building our network block. We also have our AP1 series. And so we've kind of standardized on the AX right now. And so we have our AP1 AX, AP1 AX Lite, and our AX Pro. And then we have our switches, our ruggedized and enterprise switches. And all of our switches are PoE switches. They're basically software defined PoE switches, extending that Peplink ecosystem to more ports. And
Yep,
when you
that
think
zero touch
yeah,
provisioning
it's that.
that.
Yep. And it's interesting to think about. But when I mean, I've deployed like really large enterprise networks using our SD switches, and it blows some of the Cisco guys out of their mind. Like, how are you doing this? Like, the way that we push it out is so much different because they're asking for all these features on the switch, but when you combine the switch and the router and you make a network out of it, we'll demonstrate it in module 4, but it's going to be a lot of fun, and you guys are going to have fun with it. And then we have our high performance antennas, and I've told people a lot that there's two things that matter when we're talking about performance, especially on cellular networks or Wi-Fi, and it's going to be the module and the antenna. It matters. It matters so much. The quality of the antenna will make or break whether. I mean, you could have the best of the best router, and you put a garbage antenna on that router, it's not going to perform well. And I've had I have an entire cabinet, like bookshelf of antennas, all the different brands and makes and models and cables and extension cables, and I'm just testing different antennas and how they work, and making sure the latency is there, or not the latency, sorry, the loss is there or isn't there. And so, but evaluate your antenna choice matters. And so Peplink said, you know what, it matters so much that we're going to at least give you a baseline product here that we've certified with our equipment. We know that it's going to meet at least the standard. Um,
Yeah, antennas are
so
definitely but
Ted, eSIM EID is already available in 8.4.1. That went RC last week, and I believe it's going GA soon. But yes, eSIM EIDs. I'll be releasing a YouTube video on this very shortly, and you'll be able to activate your eSIMs.
I think Nick's getting into what I was going to speak to as
Yeah, have you
well.
seen? I think
I'll tackle
everybody.
that one, Peter.
Oh, there we go. I'll let
So
Travis tackle that.
there's a lot of devils in, like, we talked about like the marketing games that gets played on the 4G, 5G, 10G, all that stuff. I think it's a similar conversation with antennas. Like, antennas are really complicated things. In reality, they're not simple and they're not easy to talk about, right? There's a lot of layers of nuance to them and the properties. And so, you look at a data sheet for two different antennas and, oh, they both got, 6 dBi of gain. Well, there's a lot of details that goes into that. Like, the gain is one thing. How they're measuring the gain. Is it average gain? Is it peak gain? There's all these layers of BS that, frankly, manufacturers can hide behind and not lie, but at the same time create an impression that this thing may be as good as that thing. And so you kind of got to just get it out in the field to really see what the difference between this 6 dBi antenna is and that 6 dBi antenna is. And what I'll say is we engineer our antennas directly in-house. We have a team of RF experts that design these antennas. We don't buy white label antennas and put our brand on them. We are designing these in-house and we're nailing it, frankly. I mean, and I'm saying that based on independent results that I've seen customers do in comparisons with third-party antennas from other manufacturers. So, we have customers in the autonomous driving space, right? They're driving all over cities, counties, countries, and they're putting all these antennas side by side and recording the data to see which antenna works the best. And the Peplink ones are almost always the one that's performing the best, and usually not the most expensive one on those test configurations. So yeah, there's a lot to the antennas, but get one and go play with it out in the field and compare it to another one, and I think you'll start to.
When you were talking about gain, I'm going to add to that. And I had literally had this conversation prior to this webinar. Is if I'm testing my a cell phone, this is not a 7 dB high gain antenna. This is gonna be like a 0.3 dB antenna on the back of this thing. It's super tiny, right? When I'm testing gain specifically or loss specifically, if my cell phone has 5 bars of signal of 5G with great reception, and I'm testing the gain or loss of a 30-foot cable, and like, oh man, I'm getting 800 megabits per second. That is not testing the loss that's happening over the cable, because you don't need 8 dB to receive the signal. you need 0.3 dB to receive the signal. And so a lot of times people say, "Oh, I was testing this antenna versus another antenna, and it was the same result, so it's equal. It's a good antenna." No, no, you want to test that antenna when it's bad. Go somewhere where your cell phone doesn't work,
Yeah, yeah.
then test the antennas. I intentionally set up testing labs where my cell phone has 0 bars of service, because if I can take 0 bars of service, I'm not testing speed. I'm testing, does the antenna advertise the gain and the noise that it's advertising. So I want 0 signal. I want my cell phone not to work, because now I'm saying, okay, I know that with 0.3 I can't get it. So now I can say, you're a 6 dB, you're a 6 dB. You're both saying you're 6 dB. What's the Peplink reading me at now with 6 dB? You're 9 dB. Is that going to give me that extra 3 dB of gain versus the 6 dB of the advertised antenna? And that's when the good antennas shine. That's when you'll start to see which antenna really is good. Is when you're testing in a bad environment. Go to a basement. Go somewhere where your cell phone barely works. You have just a tiny bit of signal, and then see if that high gain antenna fixes that. So we're going to get into that, but I mean, we could have it's a fun challenge, and I love that research. I love playing with antennas. The balance set series routers, built-in survival mechanism, no more connectivity failures. Design. Sorry, that's my sales pitch. Designed for enterprise networks, stay connected, even if WAN links break, equipped with a wide range of load balancing algorithms to handle any situation. The idea behind the balance series routers is a multi-WAN load balancing and bonding, going anywhere from one WAN and one cellular, or 2 WANs, the balance to 20/2, all the way to like the balance 2500 EC. The balance series has a wide range here. So we have our small branch office, like a balance 2, balance 20X, 310 5G, 310X, and 310 fiber. The 310 range, I'm gonna show you guys a little bit here, but it's a little bit confusing, and we'll hopefully unconfuse that for you today. Then we have our headquarters routers, the 380 and the 305, 580, 380X, and 580X. If you see the X in a router, that means it has some layer of modularity to it. Balance 710, 1350, 2500 EC, and then we're going to go into the SDX, SDX Pro, and EPX. We'll talk about antennas when we go into the actual products. Remind me, James, when we go into the actual antennas, and I'll be happy to address that. The Balance 2 is our full gigabit router. If you remember the Balance 1, it kind of is the successor to the Balance 1. 2 Ethernet LAN ports, 4 Ethernet LAN ports, USB for like a max adapter for 5G, or even another USB Ethernet WAN if you wanted to. And it's really gonna it's a great little branch router. You can shove this. It has a nice metal enclosure. You can shove it in a corner and use it. And so it's a low cost gigabit router. That's the Balance 2. It's a low cost branch gigabit router. Really competes with those budget Meraki devices, because you can throw it out there and take advantage of it. It has 150 megabits per second of speed fusion throughput, which once again for a small branch is usually more than enough. The Balance 310 5G and 310 Fiber 5G. When this came out, I was like, not impressed. Now it's one of my most recommended branch routers. Really funny. Peplink will release a product sometimes. I'm like, why are they doing that? And then I start playing with it. I'm like, wow, this thing it runs my house. I've had 380s at my house for years and years and years. That's just what I've always run at my house. And now it's run by a 310 Fiber 5G. It's once again, it's just a 1 gigabit router, very similar to the Balance 2. But we're adding 5G to it. So now it's a Balance 2 with 5G. That's 2 Ethernet WANs. Two WANs, one Ethernet, one fiber, or on the 310 Fiber 5G has 1 Ethernet, 1 fiber. The 310 5G has 2 cellular and 1 Ethernet, and that's important there. The 310 5G has 1 4G modem, 1 5G modem, and one Ethernet WAN. The 310 fiber 5G has one 5G modem, one SFP WAN, and one Ethernet WAN. And so the different deployment topologies or ideas. They're both gigabit routers, and they both support 500 megabits per second of encrypted SpeedFusion VPN. That is the fastest, least expensive VPN router we have. And that's why it's my number one branch router these days, because everybody's getting gigabit internet for pennies on the dollar these days. And they go, why is my SpeedFusion only 100 megs or 150 megs? And it's like, here, try this out. Give them the 310 fiber, and they go, oh, wow, this is awesome. And it's not that much more expensive. So for a really good price, you're getting incredible power for a branch router. And that's why it's become one of my number one branch recommended solutions, because of that SpeedFusion throughput, most specifically. And then I like the fact that it has the built-in 5G.
Mm-hmm.
Then we have the 310X. 310X has a 4G and a 5G version. So we're going to talk about the 5G just because everybody likes 5G. But it's a 2.5 gigabit router. This is based on the MBX platform, and it's modular. So the new X62 chipset comes out, boom, you can plug it in, and now you have the latest generation 5G chipset on your router without having to buy an entirely new router, or even reconfigure the router. You just mail them the router, take out the 4 screws, unplug it, take out the 4 screws, plug in the new module, turn it back on, and boom, reconfiguration. You now have the latest generation 5G hardware. If we release millimeter wave, boom, plug it in, millimeter wave CPE right in a 310X. And so you're talking about, and with 2.5 gigabits of throughput, now you're talking about high bandwidth routing capabilities in a budget friendly package. And so the 310X versus the 310 fiber or the 310, you're really going from that 1 gigabit to that multi-gigabit capability, that 2.5 gigs, and it's basically a little baby MBX. The 380 and the 380X. The 380 is one of the first routers I ever played with outside of the Balance 300. It's the first business class router I played with. The 380 is there's still a demand for it. It's a very popular router. I've seen less demand over the past maybe 18 months, but it's one of those like tried and true devices in my opinion. It's been around for a long time. 3 Ethernet WANs, gigabit router, but it's the older models, older chipset. So you're talking about 150 megs of SpeedFusion throughput. And then we go to the 380X. You get 3 gigabits router with 500 megabits of bonding. And then we also have the drop-in mode. That's going to be next. Drop-in mode I believe my first ever drop-in mode was on the 380. And so the 380. So when we talk about the 310, we get drop-in mode. But when you go to these Balance series here, you see this LAN bypass. We'll talk about it later. But the Balance routers have LAN bypass. So the 380, the 580, the 710, and the 2500 EC, you'll see this. They all have drop-in mode, but then they have this LAN bypass, and we'll talk about LAN bypass. Actually, I'll talk about now just because I'm bringing it up. LAN bypass. If I have a non-Peplink firewall, and I want to add multiple internet connections to that firewall without messing with the network, I don't want to change my public IPs. I can throw a router in drop-in mode. Drop-in mode that basically bridges the Ethernet WAN going to my firewall and puts a Peplink in the middle of it. Now, with the Peplink in the middle of that circuit, I can intercept traffic and add additional WANs. So say I have 5 IP addresses here, but I could buy another WAN that gives me 20 IP addresses for cheaper. I can then NAT those 20 IP addresses into this firewall and keep it there. Or just have redundancy, failover resiliency. So now I can take this one internet firewall and add multiple internet connections to it. It's called drop-in mode. LAN bypass says if this router fails, if my Peplink fails, the ports between WAN 1 and LAN 3, the actual 8 cables, I don't have 8 fingers, but are connected when the power's off. So the LAN port becomes just like a jumper cable. And so basically with the router off, that one link coming in, that drop-in mode link, stays functioning with the router off. Then when I turn on the router, it'll break for a few seconds while it opens it up and then turns it on. You'll break the connection, and then you'll have your regular router. But I can actually unplug the Peplink balance router and LAN bypass with drop-in mode and not affect the downstream firewall at all. And that's the benefit of LAN bypass and drop-in mode. If you're using an existing firewall infrastructure and you just want to add a single router to mitigate or to add multiple WAN connections or enable Peplink.
Yeah, that Peplink does not become a single point of failure in that network. Then
exactly
bypass,
it is pretty cool.
Kind of,
but
invisible.
You'll notice the X series, we have this new processor chipset, and so we're getting incredibly more bonding throughput as well as routing throughput. So we're going from 1 gigabit to 3 gigabits, 150 megabits per second to 500 megabits per second. And with the X, it's modular, so we have the Flex Mini module, so we can add that 5G if we wanted to.
I think it's fair to say you can ignore the 380, 580 for any new customer, right? Like, you may have an existing customer who's got those and want those, great. But the X versions are the modern.
That is correct. And if you're in sales, though, you need to know these exist, because they're still. I mean, the 380 and the 580 specifically are heavily adopted routers, and so you're going to come up against those, and they're going to go, "Hey, I want the new 580," and you're going to say, "Hey, well, here's the 580X," and they go, "Whoa, it's $1,000 more! What the heck?" And so it's important. That's why we put them side by side instead of a slide to themselves. So the 580 is a 1.5 gigabit per second router with 200 megs of bonding throughput. The 580X is a 4 gigabit router with 500 megabits of bonding throughput. Once again, that X gives us that Flex Mini module, so we can add that 5G or SFP port to it. The balance 710 and 1350 are 2.5 and 5 gigabits respectively, and then 400 megabits and 800 megabits of bonding respectively. You'll see that these heavily compete with the SDX and SDX Pro. And so once again, in most modern networks, we're selling the SDX and SDX Pro in this environment. But it's important to know these routers exist and where their value sits, because there's a lot of these in deployment. I mean, still in deployment. And they're still supported. They can still get 8.4 firmware. So still supported, still relevant routers. The 2500 SFP and the 2500 SFP and 2500 2SFP were the powerhouse before the EPX and 2500 EC. And definitely a relevant router for its price point, because it's still the least expensive M-Gig bonding router that you can get. It's cheaper than the 2500 EC and cheaper than the EPX. So it's still a relevant router when you're talking about M-Gig bonding and headquarter data center branch site connectivity. The 2500 comes in 3 versions. It is not a flex module, and it's not upgradable. It is a module, but it's not interchangeable. The 2500 is an Ethernet based router, so kind of like the 1350 and the 710. The 2500 SFP introduced 10 gigabit SFP ports, so one module swapped out with an SFP for LAN or WAN. The 2500 2SFP, which is my most commonly sold flavor of this router, has 4 SFP ports and still has Ethernet, WAN, and LAN. Once again, and it had dual PSU. So, but it's the entry level M-Gig routing support that we have. If you notice, the 1350 was 800 megabits per second, 500 megabits per second, 500 megabits, 600 megabits, 600 and 500. Now you're talking the 2500 EC, 2500. We have this 2 gigabits of routing throughput with an 8 gigabits of stateful throughput. And there's 3 models. The 2500,
like you said, fixed, and you order that SKU, that's what you've always got. You can't change it.
Yeah, they're not changeable. The 2500 EC, I don't know if you follow me on LinkedIn, but it was launched this year, I believe mid-year, and it is my number 2 router of all routers sold this year. EPX still takes number 1 slot. But the point is, this is an incredibly powerful data center hub router. You're talking 30 gigabits plus of stateful throughput, 4 gigabits plus of VPN throughput, thousands of VPN peers, thousands of user support, and completely programmable 0 to 16 Ethernet and Ethernet WAN/LANs, and then 0 to 4 SFP LAN WANs. So you're talking, multi-gig router, and it has 1 terabyte SSD for virtualization and edge compute capability. So you're talking massive amount, you're talking about branch router or a head router with, Active Directory controllers on it or VMs on it for managing security or compliance or logging or whatever you might want to do. You can put that right on this EC router. And so I can't say enough good things about it outside of the fact that it's just the fastest router that Peplink's ever made. Then we're going to go into our X series routers. I'm looking at some questions real fast. Dusty, forgotten wiring cloud typically does not have the best cellular signal dedicated wiring. Nick, let me address that when we get to the antennas. I have a fun story about that. I don't believe we support 802.3 BZ, right?
I don't think so either.
Yeah, I don't think we do. So what you want to do? Someone asked if other devices have. The 16 port switch also has LAN bypass, and then most of the balance routers have LAN bypass with drop-in mode. And I have a YouTube video on the LAN bypass on the 16 port switch for trains. It's pretty cool. Oh, did I say a different year? Yeah, it's 2024, just in case. You see how to run agents affect speed. Yes. So anything you add to any router is going to affect throughput, which is actually why it's rated how it is rated. But the idea is that with a moderately loaded router, you're going to get the throughput that's advertised.
Yeah. And that's just like any vendor, right? Like if you look at a Meraki router, they've got ratings for encrypted throughput versus stateful throughput. And if you max out your encrypted throughput, that will sacrifice the stateful throughput. And that's the same on Peplink. That's the same on, you're not going to get 600 megs of encrypted plus 1,000 megs of stateful throughput at the same time, right? They're both chewing up that CPU one way or another. So the reality is going to land somewhere in the middle if you're doing both at the same time.
And, if the router has 32 gigs of RAM and you build a VM that's using 27 gigs of RAM, you're limiting the amount of memory available for bonding and tunnels and things like that. So yes, what you do to these routers matter, and how you configure firewall policies. And we'll get into all that, by the way, in module 4. We're going to get into a lot of that. X series, powerful, modular, future-proof. Boom. Mic drop. Sorry. When we talk about the X series routers, we're looking at like enterprise and industrial. Now, give it the enterprise I use a lot in mobility. I think I've done tons of SDX Pro, EPXs in mobility. But we're looking at the EPX, the SDX, the 310X, and the 20X. These are our X series. And then we have industrial routers. We have the MBX Mini, the HD4 MBX, and then the PDX. And once again, there's X. If you see X, it means there's some layer of modularity in the router. What's missing from here is the 380X and 580X. Those should have been here too. So we're missing the 380X and 580X on this. So you have the 20X and the 310X. They're both gigabit. Well, sorry, I was thinking about 310 fiber. So the 20X is a gigabit router. The 310X is 2.5 gigs. The 20X has 160 megabits of encrypted throughput, VPN throughput. The 310X has 500 megs of VPN throughput. And then the 310X has 2 USB ports that can be Ethernet WANs. That's one of the nice things about the 310X is like you can actually have 2 max adapter 5Gs on there, or you can have, an Ethernet WAN or something like that on there as well. And then the 310X has 2 Ethernet WANs. The 20X has 1 Ethernet WAN. You can see here the 20X has the virtual WAN activation license, which we'll talk about later. But the the virtual WAN activation license allows you to add 3 additional virtual WAN inputs. In other words, you can convert LAN ports into WAN ports with the virtual WAN activation license. And you can do a lot more, by the way, and we'll talk about that later. The virtual WAN activation license will let you like take a cable modem, Starlink, and 5G and combine those all together on the 20X. Or you could do it on the 310X too. The virtual WAN activation license allows you to create one virtual WAN on a particular VLAN on either WAN or LAN interfaces. This means that you can create a virtual WAN on a VLAN for WAN port or a virtual WAN on a LAN port on VLAN for a LAN port. And why you'd want to do that is if you're trunking upstream, like to a different IDF or a different location, you can actually have the router in one location and then have a switch somewhere else, plug that switch into the WAN port with VLANs, and then have your virtual interfaces on that WAN. Or you can trunk it through your network on the LAN and go to an IDF and then have something closer. So if you have your MDF in a closet in the basement with 0 cellular service, and you want to add an HD1 dome or add a cellular internet to your network, you could do the VLAN feature, trunk that down into your switch stack, run that through your network on a VLAN 4000, then plug a cellular router into a port on a switch somewhere else in the building that has cellular service, tag that VLAN 4000, and voila, you've extended your WAN to a part of your building that has access to cellular internet. So you're taking that 5G modem and you're moving outside of your MDF.
I think this is another good feature that really helps like define this PCA as the middle certification here, because what Peter's talking about, if you don't understand how to do what he's saying, the PCE isn't probably going to be the place that you want to be looking towards, right? We're taking a few different network technologies and fundamental concepts, and we're kind of combining them to create a really cool, useful feature, but it's complex, right? The actual implementation of that takes a lot of knowledge to understand it. It's easy to do with Peplink if you know how those things work and how to lay that groundwork for that. But if you don't know what those things are or how you would implement it, this is good for you to just understand what it is. It's available. It's a feature there. So you can look back towards the sales side. So again, this is kind of like one of those like in-between types of concepts that can steer you one direction or the other, I guess, on your own learning track here.
And that's also why people like Travis exist. I mean, when in doubt, reach out to us, and we're here to help you. So the important thing is that the option exists. You're like, man, Pete said something about this, and I'm struggling. We can help you with that. I mean, and there's other partners that can help you with that all over the world. And if you're in any country, anywhere in the world, we can get you to a partner that knows how to use these things. So don't worry about that either. Like, we just want to make sure you know the basic information. That's the whole point of the PCA, is that you understand what the router can do, and then we'll help you do it. Is this the same as WAN as LAN? And no, WAN as LAN is to be able to convert a WAN port into a LAN port. So sometimes people will buy a BR1 Mini as 2 LANs, 1 WAN, and then cellular. Well, if they're only using it as an adapter, they're using it to connect, they're only using it for cellular, that 1 WAN port is prime real estate that's missing an additional LAN connection. And so you can convert that WAN port into a LAN port, and now it acts on your LAN network. And so the WAN as LAN just lets you to move those ports around.
I see a question about why having a feature through a license when the market has plenty of devices giving this feature for free. And I think the answer to that question is those devices don't do what Peplink does, right? Well, you may be able to trunk a WAN in with another product, but you don't have speed fusion, you don't have all these other capabilities. And so it's a very different question, right? Like, does that other device solve the problem that your customer's needing solved? Probably not, right? Is that feature available standard, this specific feature? Maybe, yeah, maybe. But that product probably isn't solving the problem that customer has. And overall, the ecosystem probably doesn't cost the same amount amount of money. So there's a bigger picture to the question that you're asking there, I feel like.
Well, and
Individually,
actually,
yeah, there's a there, but
I would almost disagree a little bit with that, Travis, because
sure.
a lot of products out there might offer interfaces for free, but they charge for throughput, or they might offer like
Sure.
they
Yeah.
have
Yep.
different licensing models. We are charging
Yep.
by the interface, like the 1350 or the 710 has a particular
Yeah.
interface
Yeah.
count, and so when you're looking at the interfaces, if you have a balance two and you have unlimited virtual interfaces on the WAN, that might put you into a 580 category that you're getting for. And so when Peplink's looking at and we don't do licensing the way standard people do it. Our equipment's perpetual forever. So when you buy this vWAN as LAN license, you're upgrading the router to this new feature. And Peplink does give away for free. The 20X comes with a free vWAN because it only has one Ethernet port. The BR2 Pro has a free VLAN license. I mean, there's several of the routers that have a free vWAN license, and then you can add even more on it. So we do offer it for free on some routers that don't have enough Ethernet ports, and then you buy it one time, and then you have that activated on the router forever. So but Peplink is I pride myself and being able to say that Peplink has the least licensing headaches of any other product I've ever seen in my entire life. And if they want to charge for a vWAN, I am more than happy to pay for that because it does negate on a sales side some certain different routers. And so the allows you to keep that into check with what you're selling and what you're promising, which is this bonded capacity and the ability to aggregate multiple WANs together. So that that's there. And then but yeah, it is one of those things that the vWAN license is tied into prime care and or the device, but but I'm more than like for me, I'm more than happy to pay for it because of how little Peplink does on any other license. And if you do buy it, it is perpetual. It's not a one, you don't buy it every year. But I'm not going to get into those nuances because this is training, not sales.
Yeah. I
Litigation.
think it really is just a total cost of ownership
Yeah.
conversation. At the end of the day, is you got to zoom out and look at the big picture of how much does all of this cost, how much does all of that cost, and what problems are those two different solutions solving or able to solve. And
Yeah. But I mean, I had a customer buy a whole bunch of EPXs and 2500 ECs, and they said that we were 76% cheaper, 76% less expensive than the competitor that they were using. So when I think about licensing and activations and prime care and essential care, I think about the fact that our total cost of ownership is 76% less. It blows my mind when you're looking at equal features and equal capabilities. So the 380X and the 580X, once again, these should be your industry standard when you're looking at like the 380 or the 580, especially on current router generations, because that flex module and the increased throughput. So you're talking about 3 gigabits and 4 gigabits routers with 500 megabits of speed fusion throughput, and then 3 Ethernet WANs and 5 Ethernet WANs. So really kind of taking in that that capability. But now we have, with the 580 and 4 gigabits of throughput, it gives you a lot of scalability for a good price. SDX and SDX Pro, probably outside of the EPX, probably one my most popular routers that we sell as far as balance series go, or data center routers. We sell a lot of SDXs and SDX Pros as our hub devices for like MBXs and BR1s. And the reason is because they have good throughput. You're talking gig of unencrypted, 600 megs of encrypted, but then they also support hundreds of peers. So if you have, a whole bunch of BR1s, a whole bunch of peer devices, you can, hold on one second. So the SDX and SDX Pro, the biggest difference for us, you can go, what's 1 gig and 600 megs? You have that 24 gigs of routing, but actually that's not the biggest difference between the routers. The SDX Pro is dual PSUs, has 2 flex modules instead of 1 flex module, which means you can have more WAN LAN interchangeability. And they also has edge compute built in. So you have that 500 gigs, 1 terabyte or 2 terabyte storage built into the router. So the SDX Pro is like a 2500 EC baby. You get that edge compute capability, dual power supply, um, and the dual flex modules, and you get all of that for just a nominal increase over the SDX. So it's a really popular hub device for me, especially when I'm talking about like our healthcare and professional enterprise customers that are looking for a powerful branch device or powerful head-end unit even. So it's really nice. The MBX Mini, until the BR2, was the most powerful dual 5G router I've ever seen in my life. Um, and you might see like the MBX Mini and the BR2 as competitors, but they're not really when you look at the performance of it. You have the MBX2 has 2 Ethernet WANs with PoE, so PoE Ethernet WANs, 4 PoE Ethernet LANs, 2.5 gigabits of routing throughput, and that 500 megabits per second of bonding throughput, with the dual DC input and the terminal block input, supporting 10 to 50 or 12 to 54 volts of power. If you have 48 to 54 volts, you get the PoE. If you're at the 10 to 30 volts, you get the non-PoE. But it's also fanless design and has that huge heatsink on it, and dual AP modules as well, Wi-Fi modules as well. You'll also notice on the back, it has the QMA connection. So this is the smallest router that we'll show you that has QMA connections on it. After this, you'll go to the MBX 5G, but you'll see those QMA connections. And that's really important when you're taking the MBX Mini and looking at your antenna choices, because if you're modifying an existing network and they have SMA, you'll need to make sure you include the QMA to SMA adapters to do that. And one of the logics, people have asked why we do the QMA, the density of 4x4 MIMO and how small it is, it's really hard to get your fingers in there to screw down the SMAs, where the QMA really kicks into place. Makes it really easy just to click those in.
QMA can be a little bit troublesome just because it's not as available or is not as common, but it is just a better connector all around. It's vibration proof. It clicks on instead of screws on. It's
so easy.
Yeah.
HD2 and HD4 MBX, my number one sellers in the world for me, outside of the EPX, which I've already mentioned. The MBX is a specifically the HD4 MBX has 4 5G modems, 8 PoE plus ports, 2 or 3 Ethernet WANs, and then WAN 3 has that WAN as LAN feature, so you can convert WAN 3 into an additional LAN. So if you need an 8-port switch and then you want to take one port and pass it down to another switch, you can use that WAN 3 as a LAN and trunk it down to your network. 2.5 gigabits per second of stateful throughput, 500 megabits per second encrypted bonding. And then if you look at the back of this thing, 17 QMA connections. Each modem has four connections, and then you have your GPS. And so it's just ridiculous. Then you have 8 SIM card support in the HD4 and 4 SIM card support in the HD2. So you have your primary and your backup SIM card support on those routers. So you have a really, really dense SIM card capability, as well as the ability to aggregate all the carriers. I mean, you can do like 2 AT&T, 1 T-Mobile, 1 Verizon, or two T-Mobiles and 1 AT&T, 1 Verizon, et cetera, and bond all those together and get that connected. Make sure you have that connection in there. And so you're gonna get all the internet with this router. I always tell people, and Travis said it one time the best, and it's all about increasing the number of nines, right? When you start getting into multiple internet connections, is how many levels of 9 do you want? And when you talk about the HD4 MBX or the old HD4 or the EPX with 12 5G modems, you're looking at the ability to aggregate all those internet connections together to create the amount of bandwidth you need to complete your mission. And when I talk about the HD4 MBX, everybody knows that sometimes the internet is slow. Like sometimes you go to a congested area and there's only 2 or 3 megabits of internet. Well, if you need 10 megabits or 7 megabits to be able to stream a video, well, then 3 megabits isn't going to do it. And if you bond 2 3 megabits connections together, you're not going to get 6. You're going to get like maybe 5 megabits per second. Well, if I bond 3 megabits connections together, I'm going to get that almost 9 or 10 megabits that I need. And so, and it's sort of like when I was talking about testing antennas. You don't want to test the antenna where it's good. You want to test the antenna where it's bad. I want to build a solution to work where the internet is bad, not where it's good. If I'm going to good places and bad places, I want the internet to work in the bad places as well as the good places. So if I'm getting 900 megabits per second of throughput in the good places, good for me. That's awesome. But if I can't complete my mission in the bad place, that router is not going to do it. The HD4, I travel all over the country in my little Speed Fusion van, and each of my 3 vehicles has HD4 MBX 5Gs with 2 T-Mobile, 1 AT&T, and 1 Verizon. There is one place that I have 0 service that I've driven on a main road, and that's in Standing Indian Mountain, North Carolina. Outside of that, on main roads, I'm always connected to the internet, and I have GPS tracking to prove it. And I'm driving through Arizona, driving through the deserts and things like that. I mean, you might drop like a Verizon, I might drop an AT&T, or I might drop a T-Mobile, but I'm staying connected all the time. And I know there are other areas that are dead areas, but the point is it's almost always connected. And that gives me that ability. And then you compare that with a good antenna, which we'll talk about more in just a few minutes. It creates a connection that is truly unstoppable. And then it's just a matter of adding more. And that's where the EPX comes into play. The HD2 MBX Cat 12, we have this green terminal block on the backside. This is your DC terminal. So a lot of our routers have this. You'll see this on some of the UBR has it. UBR LTE has it. The Transit Duo used to have it. I mean, a handful of routers have the green terminal block on it, and so that allows you to. It has a little thread, a little screw, and you can plug in your 12 volt or your 54 volt DC input. This little green one on the left here, this is our ignition sensing. This is our GPIO for bringing in your 12 volt for your ignition sense on your vehicle. Now, if you're running the new BR1 or the BR2 with the little 4-pin, you actually have the ignition sense and the 12 volt power built into the same plug. And then these 2 round plugs, these are your 54 volt power coming in from your AC block. On the front, you'll see your 2 Wi-Fi modems, Wi-Fi 1 and Wi-Fi 2. The default is Wi-Fi 1 is your WAN and Wi-Fi 2 is your LAN. So Wi-Fi WAN, Wi-Fi WAN. You can tell it if you want to run 2.4 and 5 gigahertz at the same time, you can convert Wi-Fi 1 into a LAN and have 5 gigahertz and 2.4 gigahertz. And then you have your 2 Ethernet ports, Ethernet WANs, and then your third one that's an interchangeable WAN and LAN, and then your 8 ports of PoE plus LAN, and then your 2 USBs. And then this little reset button, you push that reset button, hold it for 25 seconds, and it'll factory reset the router. The EPX, one of my favorite routers of all time. And they say up to 24 cellular. That's 24 integrated cellular. We've had partners do well over 40 connections now on the EPX. So it's 24 plus. And then you have anywhere from 8 to 56 gigabit Ethernet LAN or WANs based on the 8-port Flex module here. And then you have your 10 gigabit SFP module. So that's going to give you 4 ports of 10 gigabit, 1/10 gigabit SFPs. And then you have your 4G and 5G cellular modules that have either 2 or 3 cellular. If you see 3, that means it's a 4G. If you see 3 or 4, it's a 4G. If you see 2, it's 5G. So this picture down here, you can see the 8 antennas and the 1 GPS and then the 2 bays there. That's a 5G. This pictured here is 4G. 30 plus gigabits of stateful throughput, 4 plus gigabits of Speed Fusion throughput, and an optional 1 terabyte internal storage for virtualization. And you have to have an LCD module that supports the 1 terabyte, and that comes with the router. I'm going to go back to the SDX real fast. Something to note, engineers, this is really specific for your engineers. The SFP interfaces on the SDX and SDX Pro, these are 10 gigabit only ports. They're not 1/10. The Flex module is 1/10. So if you are trying to plug a 1 gigabit per second transceiver into these modules and you can't get on the internet or it doesn't light up or doesn't negotiate, it's a 10 gigabit only Flex module. If you need 1 gigabit on the SDX or SDX Pro, you must use the Flex module here because these are 10 gigabit only. The PDX is a briefcase Peplink design. There are thousands of, I'm joking there, but there are a lot of people making mobile kits out there. I make them in my company. I've got friends and peers and competitors that make them as well. This is Peplink's answer to it. I think they did a darn good job. It has external watertight Ethernet ports, DC and AC input, external Ethernet port, power port, and then inside it has like a patch panel that you can connect your Ethernet WANs and LANs to. It has a SIM injector or SIM extenders that are used for connecting the 8 SIM cards because it's basically an HD4 MBX inside of a case. So you got that 2.5 gigabits of throughput with 500 megabits of bonding. And then it has 3 modular bays that you can add additional Speed Fusion engines or batteries to increase the number of internet connections or to add battery backup. The HD series.
Yeah, there's a lot of people that make cases, like you said, like Peter. We're not trying to compete with that there. That product it's a niche, but there's customers like government specifically, they want something that's manufacturer supported. Yep. Right. Some customers just have technical red lines, and that's one of them that we've ran into of, yeah, great, Peter, you can build a case, but this is, US government, blah, 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 and we need the vendor to support that warranty,
oh, yeah.
blah, blah, blah.
And it's a neat router. I mean, I have one. It's a neat box. But there are partners out there that make cases, and I want to make, it's expensive. So it's expensive. And it is really built
if you're
to
a partner,
that box.
Just don't let it discourage you as a partner from doing your own case solution too, right? This is appropriate for some situation. We're not trying to build a whole bunch of cases under our direct product line.
Yeah, that case is the PDX design though has been around for a while now, though. I mean, we started with the HD4, then went to the HD4 MBX, and now we have the 5G version. So I think mine's the 4G version, so I need to upgrade. But so we have the 5G version now. And then we have the HD series. The HD series, you saw that I mentioned, you'll see duplication. So you have the HD. The HD is high density. It's not heavy duty, it's high density. And the whole idea is multiple SIM cards or multiple cellular routers, modems built into the router. And so you have the HD1 dome. This was started as the HD2 dome, and then it has 4 antennas in it. So when you go to 5G requires 4 antennas. And so you have the HD1 Dome Pro, which is our single cellular, even though I just said multi, but HD1 Dome is our single cellular 5G dome, and it is incredibly versatile. One of the things that I really like to do is take 5 or 10 or 20 HD1 domes and plug them into an EPX or an SDX Pro with the PoE Flex module as WAN ports, and basically have a 0 loss antenna on the roof. So I can take an EPX, take 12 of these domes, put 12 of the domes on the roof of a vehicle. That's my antenna and my modem, 0 loss. The antenna is right there and attached to the modem. And I run just a single Cat6A cable from the modem down the router down into the EPX, plug it in to a Flex module configured as a WAN port with PoE. Boom. Now you have 12 5G modems with 0 RF loss from the roof to the EPX down below. So it's incredibly versatile capability to extend your infrastructure. What's missing from here in these slides, maybe just didn't get produced at the same time, is the HD2LR. But so we have our single, and then we have our multicellular. So you have the Duo Pro or the Pro Duo. That's going to be 2 4G modems. the HD2 IP67 watertight, waterproof connection, the HD2 Mini. And then once again, we have that HD4 MBX and the PDX. And like I said, some routers meet multiple categories. And you can see here the HD1 Dome, the Dome Pro, and the HD2 Dome. The HD1 Dome and HD2 Dome are 400 megabits per second, whereas the Dome Pro is a gigabit, kind of based on the BR1 chipset. And then you see here that the HD1 Dome and the HD2 Dome only support 100 megabits of bonding, unencrypted, and 60 megabits of encrypted, whereas the Dome Pro supports 200 megabits of encrypted and 400 megabits of unencrypted bonding. The new Dome Pro LR, I did not realize how big this thing is. If you haven't seen one in person, the thing is massive. This thing is huge. It has this thing is designed for maritime. We are now using it to provide building backup. So we install these on the roofs of these really, really tall, like distribution buildings. And then basically it's a single cable down. And I've plugged these into Meraki's. I've plugged these into Peplinks. You set up bonding because it's two 5G modems built into this thing with these super high gain antennas. We talk about antennas with gain. The super high gain antennas, no RF loss because it's going right into the module. And then you have a Cat 6A cable going down. You bond the two 5G modems together, plug this into a Meraki or a Peplink or any router you want, and boom, you have bonded cellular backup with no RF loss. Somebody asked if the domes are directional. When they're like this, they're omnidirectional. When they're like this, they have like the radial pattern is like a donut with like a tower. So when you aim them this way, they'll actually act like a directional antenna. When you aim them up and down, the donut pattern around it will cover this as an omni for the domes. So a lot of times, if I'm mounting on the top of a building or a mast, I'll mount them like this and then fix it at a site. And then if I'm on like a vehicle, I mount them upright so that they omnidirectional. The Dome Pro LR is released. You can buy them now. So just contact your partner if you want to buy them.
Short story. There's all of our 5G and all of our antennas support 5G. So
short story is all the antennas work. Dome Pro is we've tested this miles and miles offshore. We've tested this in the middle of nowhere. I wish I could get some sort of bolt to mount it to the top of my vehicle and just drive around with it. But it's awesome and very
powerful. 5-gallon bucket.
Practically. Yeah, it's huge
from a size perspective. It's a Home Depot bucket, but like you said, Peter, it's fixed and mobile locations. It's a great product for that bulletproof. I just need it always connected to the use case.
If you're in an area where the internet doesn't work well, you plug that in, it's going to work. And I'm saving my story for the antennas, and I'll give it to you when you guys get there. I get distracted. Nice. I get distracted a lot, but I have a couple of stories about antennas, but I'm going to save that for the antennas. So you have the HD2 and HD4 IP6. I believe these were end of life at the end of the right. These are not purchasable at this stage. The Transit Duo Pro. Once again, if you've been around Peplink for the last 3 years since COVID and stuff, we've had an emotional roller coaster on the Transit Duo. I believe this has been standardized here now with the Duo Pro. It's USB-C powered or terminal block powered. Or DC block powered. So you have your GPIO, I'm sorry, this is not terminal. This is RS-232, right? VCC.
Serial block.
Yeah, that's your serial block. This is your terminal block. And then you have your USB-C. I apologize there. Yeah, so terminal, serial,
you can
USB-C power.
There's 2 power ports on there too.
Oh, you can? Okay. You can't. Yeah, VCC
and ground. VCC and ground there on the farthest left. Yep.
Okay. So you have power via serial, terminal block or DC input here via the standard 4 square plug. And then you have your USB-C. And you can actually have 2 USB-Cs go into 2 batteries and have redundant power. So there's a lot of powering options was the point behind it. Then you have your LAN, and I believe this is WAN as LAN. So you have 2 LAN ports. It's 2 4G modems, GPS, and then a dual mode Wi-Fi. So you have your Wi-Fi 6, and you can do as WAN or as LAN and as LAN at the same time. So you can have Wi-Fi WAN and Wi-Fi LAN at the same time with this single modem. And then you have your
Yeah.
4 SIM cards, 2 for each modem. But it's a
I
full
think similar
gigabit.
to what we go.
Sorry, I was going to say, but it's a full gigabit and 200 megabits of bonding with 8 gigabytes of internal storage for Docker support.
Yeah, and this is another one of those products that, you see this used in fixed and mobile locations. I see it in vehicles, I see it in backpacks. And so all those different power inputs allow you to use it for a lot of different scenarios. If you're a broadcaster, you can throw this in a backpack. You've got 2 USB-C power banks. You can hot swap those power banks. You can keep running, go live, go anywhere, stay charged. But you can bolt this into a bus and use this as your hotspot for a bunch of people in a vehicle too. So those different power options give you a lot of different capabilities or scenarios that you could use this in.
Yeah, definitely. And then we have the BR1 series. Now, I wish they'd called this the BR series because you have the BR2. So really it's not the BR1 series anymore. It's the BR series. Because now we have the BR2, which is actually an incredibly popular router. This has blown up over the last 6 months, especially with the release of the X62. But our BR series are like mentioned previously, kind of the budget friendly, business ready, I believe is what BR stands for, or business rugged or something like that. Business rugged, I think is what it stands for. But the BR series are those budget friendly routers that we have the single and the dual now with the BR2 Pro, and then the BR1 IP67, which I don't know if is released anymore. Once again, I think that one's out, but I'm not sure. I'll have to have Travis check that one. But one of the things about the BR series is there's a lot of them. It's probably as much BR routers as there are the other ones I've just talked about. And the reason is Peplink has they get industry requests. And one of the things I like about Peplink is like if there's an industry request that's specific, that needs a specific need, like if it works with the business model, if it works within what Peplink is doing or their vision, they're going to build it. And there are a lot of BR1s that meet a bunch of different needs. And it's really cool to see how Peplink adapts to those needs. Like the BR1 Enterprise with PoE, or the BR1 Mini Core that has no Wi-Fi to meet our secure access adapter type needs for enterprise customers. The BR1 Mini Hardware 3 takes the old BR1 Classic and makes it small like the BR1 Mini and gets that Cat7 modem. And we'll talk about all these throughout the next stage. But the idea is there's a bunch of different BR1s out there. And the reason they're out there is to meet specific needs of the customer. And so as a sales engineer, if that's what you're on this call for, it's important to know that there's a bunch of routers for a bunch of different needs. And as an engineer, if you're doing deployments or if you're the IT guy doing the work, doing the installations, then you get a unified ecosystem, but you have different requirements to fit your different missions. And so it's important to know that they're out there, and it can get overwhelming, but it doesn't have to be. We're going to start with the UB. Apparently, we're going to start with the UBR and UBR Plus, even though we just said BR1, BR series. We need to fix that title slide. The UBR and UBR Plus, the UBR Plus came out earlier this year. And if you look at the specs, it's 900 megabits of stateful throughput, 60 megabits of bonding. It's a dual 4G router for an incredibly low price. And really it just knocks the socks off on budget friendliness dual cellular router. I like to consider this a hotspot router. I've always sold it as that. It's kind of like you give it to your technicians, and they got T-Mobile and AT&T, and they basically have internet everywhere. But I had a retail chain buy these and power their entire stores off them. I mean, the entire store, no cable modem, no fiber, like literally the entire retail store, multiple stores, UBRs. It's incredible. So if you just need that resiliency and reliability of dual carriers, or you want dual carrier backup to your Ethernet WAN and have a strict budget, you definitely should look at the UBR Plus. And it's so affordable that you should buy one just to play with. Then we're going to go to the BR1 Pro and BR2 Pro. The BR1 Pro is a single 5G modem router, and the BR2 Pro is a dual modem 5G router. So you have they both have 2.5 mgig ports on them, and so you're going to have one or two 2.5 gig mgig ports. Then you have either 2 or 4 Ethernet LANs. Both of them are 1 gigabit routing throughput routers, and both of them are 200 megabits of bonding, but that BR2 has the 8 gigabytes of internal storage for Docker support. Also, the BR2 has USB and RS-232, whereas the BR1 does not. And that RS-232 is going to come important when I talk about in-touch and out-of-band management. So BR1, Ethernet LAN, Ethernet WAN, SpeedFusion. Okay. 2 5G modems, USB 3.0 port. We have our serial RS-232. Oh yeah, the DC input has that ignition sensing as well. And then it's Wi-Fi 6. SpeedFusion engine is now BR2 Micro. The SpeedFusion is not a budget-friendly version of the BR2. Well, technically it is, but not compared to like a UBR or something. So it's dual 4G, 60 megabits of encrypted throughput, but it's at the small size packs a punch. This is built for like your robots, your drones, your IoT. If you need dual 4G and a tiny package, that's, I mean, the 2.95 by 3.25 by 1.65 inches. This thing is tiny. And even it's so tiny, those connectors are not SMA connectors. Those are connectors are those MSC or MCS or something like that connections. So the really tiny cellular antenna connections. Supports 10 to 30 volts DC and only consumes 18 watts of power max. Low power draw, dual modem, bonding, perfect for robots, IoT, drones, etc. An incredibly powerful router, but now called the BR2 Micro. BR1 Mini 5G is a new product, I think just recently announced, like the past couple weeks or a couple days. So this is sort of Peplink's response to the adapter market. People are saying, "Hey, I need a 5G adapter." Okay, well, all of our routers can be in drop-in mode or pass-through mode, so I don't, they're all adapters. But we need like a budget-friendly 5G modem that we can connect to any router or anything, and that is the BR1 Mini 5G. So 300 megabits of routing throughput. It only supports 20 or 60 megabits per second of bonding, but once again, it's a single. This device is designed to be an adapter, not a SpeedFusion bonding router, and so it's incredibly price competitive. Definitely reach out to your partner if you want to learn about it, but it's half the price of a BR1 Pro, but it has no Wi-Fi, and it's only 300 megabits of throughput. But it's designed to be that adapter or that connector for your existing infrastructure.
Yeah, we see a lot of companies that are focused on 5G not because of performance, right? They've got kiosks or industrial sensors. They just want that life cycle. They want that radio, that long-term connectivity with the compatibility with the carriers, right? They don't want to do 4G today and have to sunset that in a handful of years. They want that life cycle. So a lot of people just don't need that massive speed, right? And even on the fixed wireless side, a lot of the carriers have fixed wireless 5G plans that are capped at 100 megabits. So again, this is a great adapter, so you can add 5G to your Meraki or add 5G to your existing firewall and pair it up with one of those great fixed wireless plans.
Exactly. And then we go into our SD switches. So now we're going to talk about like completing the ecosystem with the SD switches. So we're ending the near of this. I think we could finish this module, which will be exciting to get it all done in one show. Scalable LAN management. And that's really what we're talking about here, is scaling out those Ethernet ports, that LAN to your network. And so we're talking kind of like a smart layer 2 switch in a sense. We're going to have the VLAN tagging capabilities. We're going to have VLAN support. We're just not going to have the routing support. We're not talking about layer 3 with routing. We're talking about a really nice, smart layer 2 switch. We will have VLAN support, and we have interface capabilities on those VLANs. but we're not going to be routing or doing OSPF or BGP to the switch level. The router is going to be your core. Think of it, the router is your core switch, and then the switch is extending that infrastructure, especially related to that zero touch management. So we have our ruggedized switches, 8, 16, and 24 port. These are fanless designs, very, very nice and rugged. They're heavy. These have these huge heat sinks across the top of them. All the 8 port has 8 ports of PoE plus capability. The 24 port has 24 ports of PoE plus capability. The 16 is 8 ports of PoE plus, 8 ports regular. We do not support 802.3.BT, I don't believe. The 8 and 16 ports are 1 gigabit SFP, and the 24 port is 10 gigabit / 1 gigabit SFP. The USB port on the routers, and the 16 port has one on the back, it can be used for out of band management. You can actually enable external access and then plug like your phone in hotspot mode, and then it'll get that router on in control so that it can download its VLANs or its configurations. Somebody asked if the BR1 supports drop-in mode with LAN bypass. Only the balance routers have LAN bypass support, and then the 16 port switch has that LAN bypass on ports 7 and 8.
I feel like there's some confusion on the term there, though. Bypass.
Yeah,
like
LAN bypass.
IP pass through. You can do drop-in mode. It just doesn't have that physical pass, that physical feature, but it supports drop-in mode and it supports IP pass through.
Yeah, and we support. I think it's AF and AT, I believe, right? 802.1 AF and AT is our PoE standards that we support on this generation switches.
Yeah,
and then on the enterprise switches we have, and these are dual 54 volt DC input. So it comes with one power supply. You can buy a second, and it's the same power supply used for like the MBX Mini and the MBX as well. That 54 volt DC power supply. And then on the enterprise switches, 2 power inputs, 3 power supplies, 800 and 850 watts of PoE of power for PoE, but for increased PoE budget, 4 10 gigabit SFPs and 2 10 gigabits SFPs, USB for out of band management, and then and they sound like a rocket ships when they're taking off here, but because it has all those cooling fans. But they have 3 power supplies with 2 power inputs. So you can take 2 power inputs, 2 UPSs, 3 power supplies. 1 power input, 3 power supplies. 2 power inputs, 3 power supplies. So you don't lose half your power budget if you don't have that second power input. So really neat. You can see here the number of LAN interfaces, 8, 16, and 24 with the AT and AF support, PoE plus, 2 SFP plus ports, and then on the 8 and 16, 2 regular SFP supports. You have 20, 36, 88, 88, and 176 gigabits of switch capacity. The rugged switches are AC 100, 240, and then DC 54 volt. And then the enterprise switches have the like regular C13 computer plug, so with redundancy. And then the enterprise switches have the 3 redundant PSUs. And then here you can see they have a 20 watt system budget. So if you're not running PoE, you're only running 20 watts, incredibly industrial capability there, 20 watts of power. And then if you're running PoE, you'll have 90 watts for PoE plus, up to a budget of 240 watts. And then you have this 850 watts on the 24 port and 800 watts on the 48 port. And then we'll go to our APs. The APs, we have the AX Lite and Pro AX. So we have our AP1 series. We have the that's irrelevant. We have the okay. AC Mini is gone, right?
Yeah, that's
okay. Sorry, guys.
That's the AX Mini.
Yeah, let me see. Okay, here's the AX. I'll just go to the AX. So Wi-Fi 6 4x4 MIMO, 2.4 gigahertz up to 1.1 gigabits, and then 5 gigahertz up to 2.4 gigabits per second. 256 concurrent users, and then you have the 25 dBm on 2.4 and 25 dBm on the 5 gigahertz. Has a 12 volt DC input, but it also is PoE plus input capable as well. The AX Lite, the AX also has a 2.5 gigabit MGIGS Ethernet with PoE for input. The AX Lite is a 1 gigabit Ethernet, 2x2 MU MIMO, 2.4 up to 574 megabits, 5 gigahertz up to 1.2 gigabits, 256 concurrent users. It has the 12 volt DC input as well as PoE input. The AP Pro AX is Wi-Fi 6, 2x2 MU MIMO. Once again, that 574, it's IP67 rated, 256 users. So this, you can mount this directly outside with the IP67 rating. There are currently 2 current generation 5G chipsets as of today. The diagram, so Michael asked, could the SD switch 8-port rugged be powered via PoE? The diagram shows this as possible. I've never tested this. Travis, do you know anything about that? You don't believe it can? Okay. I didn't think it could. There's a diagram that kind of shows it, and I had it removed. Sorry. But yeah, I don't believe the 8-port switch can be powered via PoE. And then none of our current gen switches support MGIG. So I believe we're on a hardware refresh cycle in 2024, but for the switches, but the current generation switches are not MGIG, they're 1 gig. So our 5G portfolio, I've broken this up into the 5GN and the 5GH, except for there it is. So we have the 5GN and the 5GH. So I'm gonna start with the 5GH. The 5GH is the X55 chipset. So these are the kind of current gen 5G for the end of 2023. So you have the Max adapter, the BR1 and BR2 Pro 5Gs, the 310 5G and 310 Fiber 5G, the MBX Mini and MBX, the 310X 5G, and then the EPX, and these things don't really matter because those are flex modules, but the flex module has a 5GH flex module. And then the Dome Pro LR, the HD1 Dome Pro, and the Dome Pro Duo, these are all 5GH chipsets. The 5GN, we have basically
the Dome Pro LR shouldn't be on that first. There's no 5GH, but
okay, I didn't think so. I kind of read that a little shockingly.
A couple prototypes had it, but that's not worth.
Okay, I thought product. So the HD, the Dome Pro LR is a GN product. I thought that was it. I kind of read it a little hesitatingly there. So if you buy a BR2 today or a BR1 today, it's going to be a 5GN. Those are 5GN. The 310 5G and 310 Fiber 5G I believe are coming soon with the 5GN chipsets. MBX Mini have 5GD, 5GH, and 5GN because they've been around forever and they're awesome. And then once again, the SDX, EPX, those are going to be flex modules. So you're going to get the 5GN or 5GH flex module. And then the Dome Pro LR, that's 5GN release. The PDX, once again, that's based on the MBX chipset. And so just make sure you get the 5GN version of it if you want the latest 5GN chipset. There's a comparison table. So we talked about all these routers. We talked about all these features. So I want to show you the comparison table here. So I'm going to open up Edge. There we go. So if you go to compare.peplink.com, and I apologize, I got to put this in my window here because I can't see the address bar. It's going to take you to a comparison chart tool. And so I can choose like the HD4 MBX and HD4 IP67, and we'll do an EPX just for fun. So we can select these routers, and then you get how many cellular connections it has. You can compare your Ethernet interfaces, your stateful throughput, your bonding throughput, your storage capabilities, all of your interface options, performance. So number of users right here. Important when you're scaling out your network. How many SpeedFusion peers can it have? The first number is how many it comes with. The second two numbers are upgrades. How many APs are supported if you're going to use the AP manager. what modems come with it. And this is important because you can see how far back the router goes. So I mean, you have the Cat 12, then you have the Cat 12 FirstNet, then you have the Cat 20, then you have the Cat 20 ESN, then you have the 5G. Band 71 works on the Cat 20 and the 5G. But if the router's been around for a long, like the EPX or like that other one with the Cat 4 modem, no, you can't buy one with the Cat 4 modem anymore. It's just that's there because you could have one with a Cat 4 modem. And then you can see all the different Wi-Fi options, the hardware versions, the current generation, VPN functionality, hardware specs, power input, power capabilities, PoE, like all those questions you guys are asking about. What's the PoE standard? How much power does it take? What's the throughput? All that can be found on compare.peplink.com. And it's an incredibly powerful tool that gives you all of your certifications, your notes, what the router has, and you can compare different routers. So the default option up here is series equals max. If you change the max to balance, it'll give you a different drop-down list.
There. There's that little,
oh, yeah. There you go. There you go. Balance, max, SD, they added that. SD switch. And so you could choose balance or max and then switch between them, and then you get all the balance routers too. And then max, and you get some of the max. Well, there you go. Oh, it was updating. You get the max routers. So so you can switch between balance, max, and APs and get the different criteria pretty easily. If you're thinking about for the test though, compare.peplink.com. If you're looking at trying to quote out an infrastructure, compare.peplink.com. If you're trying to figure out if the router has a particular feature, compare.peplink.com. You're going to get the answers you need from compare.peplink.com. It's a great tool, and I use it all the time. So attributes and specs. Hold on a second. Where am I at? I got lost where I'm at. So we already went over attributes and specs though. Router throughput, captive portal. Okay, that slide's in twice. I apologize. That's it. We've already done that. We went over that. Oh, remote SIM. Some of our routers support remote SIM capabilities. Remote SIM is the ability to use the SIM injector, which we'll go over in just a minute. But it is it is kind of a cool feature, and it also supports by the Fusion SIM, which once again I'll talk about later, but it's kind of cool to mention. LAN bypass, once again, if the router's off, it'll pass through. Balanced series routers have that. You'll see that little connector there that connects the LAN and the WANs together. And those are your bypass ports. Okay, there we go. Now I'm caught up with where I want to be. How to compare devices. Okay. Sorry, guys. I was just trying to catch my brain up where I needed to be. So selecting the right product is we talk about how to compare devices, the 4 levels of connectivity, and some case studies. And I don't know how much time we're going to have left. We might have to stop before. I don't know if we're going to get through all this, and I don't want to rush. So we'll get as far as we can, and then we'll continue at the next series. Selecting the right product. So, and then how to compare devices, the comparison table, and the data sheets. From the comparison table, if you're there, you can scroll down right there. So the router has the data sheet. So when you go to the compare.peplink.com, you get the tech specs PDF. You can click on that and download the data sheet for that router. And so it's an easy way to get all the data sheets as well as all the specs. So with the four levels of connectivity, Peplink has defined, we have the mission critical connectivity. That's going to be like your public safety, your broadcast, your telehealth, and maritime. Then we have our essential connectivity, like banks, enterprise, construction, and large events. Better connectivity, retail, small offices, pop-up stores, home offices. So the idea is increasing the reliability, because most retail, small offices, pop-up stores, and home offices, they're going to have like a cable modem with best effort service. And so the idea is increasing the reliability that was like a 5G or Starlink or some other additional connection. And then we have our wireless connectivity. And that's the only time you're going to hear me refer to wireless. Cellular as wireless, meaning that we're connecting over wireless technologies like cellular or Starlink for remote work from home, transport, IoT, and maritime or ships. Factors to consider when we're talking about selecting the right product: requirements, which we've talked a lot about; budget, which is a key constraint by your sponsors. So even though the EPX might fit everybody's need, not everybody's going to buy an EPX, and we know that. Otherwise, we'd only sell EPXs. And so, the idea is that some people have a budget of whatever it might be. And so we're trying to fit the expectation and the requirement in the budget. And that's how we find the right product. And then the expectation, or what I like to define is like the expectation on the mission. A lot of times, like, what's the maximum this router can do, or what's the maximum you can do? And that's really not relevant question. What's relevant is, where are you working? What is your mission? And can the router achieve that? Because that's really going to be the answer that you're trying to accomplish is, can I complete my mission? And can I do that on budget? And within the parameters that are being described. And my example of this, one of my examples is my mobility, my healthcare mobility. And healthcare mobility, I was challenged with the idea of transmitting real-time mobile mammography images in real time to a PAC server to radiologists to review. And the idea behind it is, or the challenge is, and there's a couple challenges, but the challenge is, these amazing people out there serving, like doing these mammography scans, and trying to serve the public, but because they're mobile, sometimes they don't have the connectivity, or they can't get those images back to radiologists for review. And sometimes what happened is, especially in the underserved areas, they'd go out, they'd do the scans, they'd drive back, they'd dock the laptop, they'd plug it in, upload the images, radiologists would review and say, hey, we need to see this person again. And they can't find that person again because they're just in underserved areas that might not have that capability. And so what they wanted to do was be able to act like they were the hospital, send these images back to the PACs, get them reviewed, be able to flag potential concerns, and then invite those people back for a follow-up visit. And so we need to be able to transmit very large radiology images in real time, near real time, and with no packet loss, because DICOM protocol dictates you can't lose a packet. You can't lose an image because that could be a false reading. And so we have to transmit those images in real time and without packet loss. And so because we have high bandwidth needs and high gigabyte needs, the EPX router became my choice of my primary choice, because it supports the 12 5G modems. I've done 4G and 5G, so depending on which picture it is, you'll be 4G or 5G. I believe that one's 5G. So you have the 12 5G modems, and then what we do is we bond T-Mobile, AT&T, and Verizon together, and then we enable WAN smoothing, and that's going to eliminate packet loss. So those images get sent in much without having to be retransmitted and or mitigating the risk of failure or packet loss. And so, but more importantly, we get high upload bandwidth and high gigabytes, and that's where the EPX has this like kind of it's a secret weapon. When you're talking about sending terabytes of data per month, the cell carriers go, oh yes, terabytes, cha-ching. But these nonprofit healthcare organizations are going, whoa, I need this to be like free. And you're going, how do I balance terabytes of cha-ching and free? And the EPX, because I have up to 24 SIM cards, I can not only manage bonding for speed and performance, but also for gigabytes, because now I can buy $50 100 gigabyte plans, and I can combine those together and have pennies on the dollar, or pennies on the gigabyte data plans that otherwise would be metered and be paying a lot more for data. And so by being able to combine multiple 100 gigabyte plans, I can now have 1.2 terabytes of data or 1.8 terabytes of data for a really affordable budget compared to a metered plan to just transmit those images. So it's really neat to be able to load balance not only the performance but also the gigabytes. Once again, completing the mission and setting the expectation, and within the budget. And so even though the EPX is expensive, in compared to the metered price, the typical ROI of an EPX is only a couple months. That's how much they're saving on bandwidth. And that's where we're able to balance that expectation and the budget. And we go, hey, I know this is expensive, but when you compare it to a metered plan to support these terabytes of data, we're able to cut the costs significantly. We will talk about plan capacity and switching on module 3. So please stick around for module 3 and we'll talk about that. And actually, this question from Robert, Travis, you might have to answer that one.
Okay.
Yes. Most of our modern routers support the remote SIM device.
I don't know the dial-up APN one, so I'm not sure what.
Okay. Yeah, we'll have to follow up on you on Robert on that one. We're not exactly sure what a dial-up APN. We do support custom APNs though, and we support PPOE authentication. So that might be the answer. Is we support PPOE and we support custom APNs. So maybe. But I actually can't. Yeah. But I can't officially answer that question. So here's my schematic, and somebody asked about ports and stuff. So you can actually even see the ports required here. So this is my schematic. You have an EPX with the 10 or more 5G modems being bonded back to an SDX. I come in on my WAN interface, and I come in on SpeedFusion using 4500 to 4504 and 32015 to 32019. That's allows me to do subtunnels. We'll talk about that later. And then we connect the LAN to the customer network, and we set the IP address, the DNS, the FQDN, and then allow that access to the customer network. And we do a default route 000 to the customer network, which sends everything out their firewall. So the mobile unit is connected and then routes out the firewall. Really easy way. It's non-intrusive, but most people aren't affected by it. And then we're able to get it set up. But you can see there we have outbound firewall ports for in control. We need access to ac1.peplink.com and ac2, as well as we need working DNS and network time protocol. And so as long as all that works, the Peplink can work behind a firewall and still function. Another use case, which I believe this is Travis's use case anyways, I think you personally worked on this project, is a mobility and transportation. And the idea is providing connectivity to workers while they're being transported around. And so you have high data demands, sort of like my mobile mammography, high data demands with lots of users. So we need good Wi-Fi and bonding. And so what they set is a PMU to convert 12 volt to 54 volt for PoE. Then they have APAXs lights spread throughout the vehicle. This is going to give you a user density as well as keeping the signal strong for performance. And then that has the 4 5G modems, and we do bonding and traffic shaping to the Fusion Hub, that access to the data center, but also access for identity and access control. So when they get on the bus, they can swipe in, get on the network, start working, and that's all done via the HD4 MBX Fusion Hub and the PMU.
Yeah, I like this one because it speaks to your question of what's the mission, what are the expectations, and what's the budget, right? Because if we don't ask those questions and all you hear is kind of that frontline ask of like, hey, I need Wi-Fi on my employee shuttle buses. Okay, cool. Let's put a BR1 Mini in there or a BR1 Pro 5G. Right? If we don't dig into any details, we don't know what we actually need there. That for this customer, they expect office grade internet mobile, right? These are buses that go, tens, hundreds of miles. And so like you talked about, any single carrier is going to have a dead spot over the course of that mission. And so for this customer, they need their engineers on this vehicle coding, writing software, doing meetings, right? Doing things that they do in the office, but mobile, and they need it to work like it's in the office, not like, you're going up and down a hill and losing signal all the time. Right. And so the mission just isn't solvable with a single radio product or even a dual radio product. The mission requires that constant connectivity to all the carriers and redundancy on top of that. And so, that's how you end up with a solution like this, because the mission requires it. It's not just a oh wow, that's cool, and I want it to be fast. It's no, I need these things to work this way. So in this case, it's a technology company, and they've got a fleet of buses that they operate to transport their employees around. And so it's work time when they're on the buses, which is a great
And
perk for the employee. But so it's a win-win in that sense. Yeah, it's a fairly specific use case, but it's a big project at the same time too.
yeah,
So
and I believe they're running hundreds of terabytes. I mean, they're using a lot of data,
yeah,
right?
they're
Yeah. Okay.
yes.
So yeah, I mean, it's a big project, but it's a really neat one too. And the reason why we're keeping it vague is because I mean, obviously NDAs and stuff. Um, so I don't know if people know this, but I own an ice cream store. So this is Bob's ice cream store, and so so we use the balance 20. We were challenged with the idea that, and this actually was a real scenario. So when I bought the ice cream store, there was we had a point of sale system, and I've never used point of sale systems, by the way. I mean, I run QuickBooks and whatever financial systems that we run in our business. And so we had like a cox cable internet, and what would happen is it would get interrupted and the whole POS system would shut down. It's all this cloud system and the whole thing would shut down. And I was like, this is stupid. And so I took a 20X with a SpeedFusion Connect SIM, the SpeedFusion Connect LTE, and plugged it in there, plugged the cable modem into the 20X, and I set up WAN smoothing for the point of sale VLAN. Obviously, with PCI compliance and credit cards and stuff like that, it needed its own VLAN, and so I did that. And that VLAN then goes out SpeedFusion Connect, and then it's firewalled and only talks to the controller or the company that it talks to. And and so then what would happen is literally if the cable modem failed, the credit card transactions, the whole point of sale system literally just moves over to either Verizon, AT&T, or T-Mobile because it's SFC Protect LTE. But it would just fail over to that SpeedFusion LTE and keep working. And now what happens is they'll get a text, hey, the guest network went down. But I could get on the internet. So the employee Wi-Fi and the point of sale Wi-Fi will work over the SpeedFusion LTE. But the guest Wi-Fi we shut down when it fails over. And so then we just open a ticket with the cable company, get it fixed, we fix, the cable comes back up, and then voila, they're back up and running. And it's incredibly cost effective. I mean, the 20X is a very budget friendly router. It has that Wi-Fi with captive portal, the guest network functions. And then if the cable modem goes down, we still have access to the network. We can still get the point of sale functioning. The employees still have their infrastructure, and it keeps the budget friendly for a little low volume ice cream store. And so, incredibly fun. And we kind of made a little funny video about it. If you've seen our little, be like Bob and get the balance 20X, but basically if that uses that hot failover, and it uses for that session persistence for the point of sale platform. And we are at 4 hours, and we're going to continue here on the next session. I'm gonna be pretty firm on that one, but I hope this is valuable to everybody. I'd love to hear the feedback about this. I don't want to rush. I mean, when we talk about this PCA training, if we rush, we miss important things, and those important things become more important when it comes down to testing and serving customers. And so we want to do this the right way, which is teach you from the ground up the Peplink ecosystem and environment and products. And I hope that is what you've learned today. And I can't wait to meet with you guys in 2 weeks for session number 2. Thank you so much, Travis, for allowing this. And we'll start right here next in 2 weeks.
Thank you, Peter, for all the time and all the knowledge you're giving to everybody here. This is awesome. And yeah, thank you everyone for joining and taking the time. Still got 100 people on here, so bravo, folks, for sticking in there with us.
I look forward to seeing you in 2 weeks. Have a good one. Bye.
Bye.